Good afternoon. This is week 9, and I am Mike Wilkes, your professor for information system security and management. Let's see, audio looks good. Using a different camera today because the high-res camera is otherwise engaged. So let me start the share and get us going. And pull up my notes. Let's see, and move them around, make them readable. All right, so let's get started. Testing and automation. Information security and the information systems we build is about trust and confidence. Trust and confidence are earned slowly and lost quickly. All it takes is one mistake and you're back to square one, needing to regain the professional and technical respect of your colleagues and the executive management team. It's a tough road to walk. But thankfully, we live in an era of computing and information technology where great things are possible, and without a lot of hard work. The effort comes in mastering automation and instrumenting good monitoring and testing. With sufficiently detailed documentation and test harnesses, even the most sensitive and critical pieces of infrastructure can be hardened, patched, deployed, and tested, potentially hundreds of times a day. Even the most, potentially hundreds of times a day if we look at some of the most successful companies that have embraced infrastructure as code, software-defined networking, DevOps, and agile development. I think Etsy was one of the first companies that blew people's minds that it had tens of releases per day. And now I think they do even hundreds of releases, small releases per day. Let's see, but you cannot run until you walk, and you must crawl before you can walk. All organizations are on a path towards improved automation, regardless of their current level of maturity in this area. One of the best ways to beat the challenge of a shortage of InfoSec analysts and InfoSec engineers in the job market is to automate what you can, and try to automate just about everything within reason. Stand on the shoulders of others and don't try to invent the wheel. Seek out good tools and frameworks that are actively maintained and part of robust communities of practitioners, be it commercial, off-the-shelf software, or open source software. All right, so here's some of the things that we're going to dive into. Testing and automation. Can't really talk about testing without talking about monitoring. We're going to talk about SOAR, security orchestration and automated response. Then we'll go into application testing, penetration testing, scripting, infrastructure as code, and what is termed DevSecOps. Some folks don't appreciate inserting the word sec into DevOps. I can agree and sympathize with that. I believe security ought to be part of everything that we do, and it doesn't require a specific call out. Otherwise, you would be inserting, dev QA ops and dev monitoring ops and other things like that to encompass that focus. But it is a term that is used, and it has some intent with its use by the folks that use it. And we'll talk about that. Monitoring is testing, right? Because every time you monitor something, you're testing to see if it works. Some extensive end-to-end functional monitoring is certainly testing, but there's other aspects of testing that we should be talking about as well, which is more ad hoc and certainly automated, but maybe not every 1 minute or every 5 minutes, such as we might instrument with availability monitoring. We're going to dive into monitoring in one of the other lectures, actually, but I just want to make a brief mention of it here in regard to testing and automation. So again, monitoring is the ability to observe and check the progress or quality of something over a period of time, and to keep it under systematic review. Instrumenting good monitoring is the foundation of good security testing and good security automation. Security events and alerts are essentially a subset of monitoring alerts and monitoring events. With security monitoring, we're looking for signs of threats, of course. What is a threat? Well, one definition would be a threat is an expression of intent to injure or punish another. Another definition of threat is an indication of imminent danger. And a third would be a person or object that is regarded as a danger or a menace. Threat intelligence is information about threats and threat actors that helps mitigate harmful events and outcomes. Cyber threat intelligence sources include open source intelligence, social media intelligence, human intelligence, technical intelligence, or intelligence from the deep and dark web. So when you talk about monitoring and security, you can not get away without talking about SIEM. SIEM is an acronym that stands for Security, Information, and Event Management. The term and the acronym was coined by Mark Nicolette and Amrit Williams of Gartner in the year 2005. The acronym SEM, Security Event Management, and SIM, Security Information Management, and SIEM have sometimes been used interchangeably, but generally refer to the different primary focus of specific products. So let's expand and look at that a minute. Security information and event management is all about log management, SIM, SEM, SIEM, and a couple of other acronyms I wanted to throw out, MSSP and MDR. So log management, just basically log collection, log aggregation, and the ability to audit what is happening on your platform. SIM is long-term storage and analysis, right? Security information management. SEM is more real-time monitoring and notification, so it has a shorter window of attention. And then, of course, SIEM is simply the addition and concatenation of those two acronyms into SIM plus SEM. And MSSP is a managed security service provider, and MDR is managed detection and response. So these product areas are pretty much build upon each other, with the last two often falling into an outsourced approach, where you pay a third party to do the task of being your SOC, right? Your security operations center, of sitting there and watching the alerts coming in on your SIM and watching for interesting events and doing the first level triage or investigation of them. You can't talk about monitoring and SIEM without talking about Splunk. Splunk was founded in 2004. At least as of last year, I saw they had something on the north side of 18,000 customers. This was a Splunk Live conference that I went to about a year and a half ago, I think. And their largest customer at the time had a subscription of 6 petabytes per day, bursting sometimes to 12 petabytes per day. So that's a significant amount of data for a customer to be consuming and analyzing and ingesting. And of course, the Splunk data model is volume-based. And so the more data you consume, the more expensive it is. Although at some level, once you reach a certain threshold, I'm not exactly sure how many gigabytes or petabytes that is, you eventually stop paying monitored, metered volume-based pricing. And you just pay some large number that you've agreed to pay with them, and they no longer worry about counting the number of bytes that are being analyzed because you've sort of graduated into almost an unlimited subscription layer of consumption of the product. A robust ecosystem Splunk provides of application monitoring and applications built in Splunk dashboards. That is one of the reasons Splunk came into existence. Although interestingly enough, Splunk started out, I think, as a command line tool and eventually evolved into a dashboard and GUI that you can use in your SOC and have a whole bunch of monitors set up on a wall and all sorts of cool graphics showing real-time stats for what's happening on your platform. There are on-prem as well as cloud-based solutions. And of course, I mentioned it's a little bit problematic to be charged by data volume because then there's kind of a disincentive to keep adding data to it since you want folks to have an incentive to ship their logs to be processed. But since it would increase your price, there's some folks that may be not sending the logs, and it could potentially lead to less visibility and less correlation to be able to understand what's happening and which log events are triggered by other activities of users or bad actors. Splunk was named a leader in their Magic Quadrant by Gartner in 2020 for the 7th year in a row. So essentially, Splunk is a bit of a Cadillac solution, I guess, as they say, right? Not the Ford truck. There are other monitoring tools that compete with Splunk in this space, Elasticsearch being one of them. I think there's a recent startup, a company called Devo, that has been coming onto the scene and trying to eat both of those other two companies' lunch with their automation and event logging. There's other companies, Loggly, I think, was purchased by SolarWinds, and Logarithm is another one. But there's definitely plenty of space, plenty of competitors in the space of monitoring. I just wanted to mention Splunk because, again, it's one of the largest. And here's an example of a Splunk dashboard that someone had put together. So let's break down the taxonomy of alerts, tickets, and logging. Alerts, these are things that humans need to take action on immediately. Tickets are things that humans need to take action on eventually. And logging is essentially no action needed. Logging is opt-in messaging, right? You don't need to email every log file entry, for all of your servers to someone because someone's not going to read their email if you do that. And I mentioned it also because I think of monitoring where people say, oh yeah, we're monitoring it. We're sending an email whenever something goes wrong. Email does not have an acknowledgement, right? Like an ACK packet. You trust that someone's checking their email all the time, but maybe, they're feeling ill and away from their computer for a while. And so you don't want to think of email as an actual monitoring platform. You want to think of it as a logging tool because you have to opt in to checking your email. Monitoring shouldn't be confused with alerting. Monitoring can trigger alerts, but thresholds have to be defined for the monitoring check so that it does not fire off and fire off too often. That would be noise, and many of those might be false positives. But it also, you don't want your monitoring to fire too infrequently. These could be overly relaxed about potential violations in the service level agreement, whether that's an internal SLA or SLAs with our partners and our customers. And again, as I mentioned before, as I wanted to point out, that email is not alerting, email is logging. Too many organizations just point alerts at an email address and they think that they have actually implemented monitoring. Email is an opt-in logging distribution channel, as are instant messaging integrations with things like Slack. Slack can go down. Slack went down, I think it was this year, maybe it was last quarter. And lots of companies had built automations and workflows that depended on Slack. And so their workflows were broken because Slack became unavailable. No system should be defined as a single point of failure, even something that's largely expected to be highly available like Slack or Amazon S3. But all of these kinds of services have shown that they're not too big to fail. And of course, alerting requires an acknowledgement of receipt of the message. And so many times people use a tool like Xmatters or PagerDuty for monitoring and alerting, because then the person has to acknowledge receipt of it. And then you have timestamps as to when it was acknowledged, and then they start working on it, and maybe they say, okay, I'll be logged in 5 minutes, and I'm going to start digging into what triggered the alert and deciding whether or not it needs to be escalated and if there's something there going on or not. So anyway, that's one of my pet peeves, I guess, about people that abuse email as a monitoring channel. Alerts. Change detection or event escalation, sorry about that fire truck, based on static or dynamic criteria. Alerts proactively notify you when important conditions are found in your monitoring data. They allow you to identify and address issues, hopefully before the users of your system notice them. So well-instrumented monitoring gives you the opportunity to have good change detection and event escalation. Tickets. Tickets are a documentation or a record of some work that needs to be performed. If an alert is not critical, then it can be processed automatically in some cases, where opening a ticket is the best way to ensure that the issue will be addressed. Take, for example, the failure of a hard disk in a mirrored disk array, right? Two disks, for example, each one has got a full copy of the data. It's a mirror. I think it's a RAID 1. A common method for handling this with many storage vendors is for the system to actually phone home and to report the disk failure. They have the capability of generating an API call or potentially sending an email saying that one of the two disks has failed. It provides all of the necessary details automatically, such as the size and the speed of the disk, the drive that failed, the part number, even the serial number of the failed disk to know whether it's under warranty or not. The vendor can then organize a site visit to replace the failed hard drive. In some cases, it's dangerous to allow monitoring to automatically generate a ticket, though, for an event or an alert. Most companies manage the workflow of monitoring and ticket creation manually or in some kind of attended fashion to avoid situations where the ticket system itself might crash overnight due to an unexpected flood of tickets for some kind of monitoring failure scenarios. Monitoring can fail, of course, and it can have configuration errors. There could be a lack of communication to the system that's being monitored. The monitoring could suddenly flood everyone's mailboxes, with 1,000 emails per minute. More than once have I seen the lesson learned where email-based alerts and tickets manage to create a quasi-denial of service effect because a few thousand or even million alerts generated emails and tickets in the space of a short period of time. Logging. Logging is the foundation of monitoring, as we've discussed already. It's the foundation of alerting. It's the foundation of threat detection and threat intelligence. You don't have any events or alerts or incidents or data breaches, or at least you don't have any awareness of them, if you don't have logging. We'll talk more about observability, I believe, in week 11. In information security, observability can be created by ensuring that logging is enabled, that requests are being traced, application tracing, and of course that metrics are being aggregated and analyzed. All right, so there's 4 basic types of monitoring I want to talk about. Basic monitoring, functional monitoring, performance monitoring, and then finally security monitoring. Although we've spoken about monitoring already with regard to incident response, audit, and observability, let's take a quick look again at the 4 kinds of monitoring that should be configured in order to provide the basis for a strong information security program. Basic monitoring. Memory, CPU, network, disk. That's the quartet of most monitoring for a server or for a service. Many of the basic monitoring tests and configurations will involve static thresholds. Some example criteria for basic monitoring to trigger an alert are maybe the percentage of the CPU utilization goes above 70%. Or perhaps the server response time is greater than 4 milliseconds. Or the result count of a log query might be greater than 100, right? These would all be static thresholds. Care, however, should be taken to also configure dynamic criteria for basic monitoring. So having a disk space alert at 90% utilization might seem reasonable, but a velocity-based disk space alert is a better monitoring check. In a velocity-based alert, the rate at which the disk is filling up is used to calculate when the disk will be full. On a small disk drive, the 90% static threshold can be passed quite rapidly, and the 100% capacity limit could be reached within only a few minutes. So even before the monitoring alert has been successfully sent and acknowledged by the on-call engineer. So this is one of the reasons why a dynamic velocity-based basic monitoring checks are a much better solution. Tools like Datadog and New Relic have this capability where they can set up thresholds and baselines that are dynamic, that are even different on a weekday versus a weekend, because your traffic and activity might be different on a weekday or a weekend. Let's see, what else? Yeah. So anyway, you could have a 90% warning and then like a 95% critical, and the monitoring, could be filling up so fast, the disk could be filling up so fast that it just shoots right past the 90%, even before it hits 95 and it maxes out at 100, the system crashes. And by that time, the on-call engineer might not have even acknowledged the alert. Functional monitoring. So functional monitoring are checks that the system is capable of giving desired functionality or not. Beyond just checking if a network address has a port open or whether a process ID exists on a particular server, or the basic monitoring thresholds have been reached, functional monitoring evaluates the response of a web request to an IP address, for example, checking the response string that comes back from that web server to make sure that the expected results are returned. This is what good functional monitoring is. So a site can be down, for example, and yet monitoring might not show it if you didn't instrument a pattern match on the response. The response code could be, oh, I couldn't give you the data you want. It could be a 404, it could be a server 500 response. And if all you're doing is ping and port monitoring, the service will appear to be up because it's still pingable and the port is still open, but it's not actually returning with functional site responses and the ability to log in or view a report or something like that. So it's important to make sure that you have specific end-to-end checks that can be instrumented in a functional monitoring test that validates whether a series of systems and processes are indeed functioning within parameters. Pulling the current balance out of a bank account from a front-end web service, which relies on the application layer to function properly in order to relay the request to the back-end database and retrieve the data. That's an example of functional monitoring. The better you get with implementing functional monitoring, the easier it will be to trust that the deployment of code or the patching of a security vulnerability on a server did not actually result in a disruption of services. So let me mention that again. People that set up monitoring oftentimes don't go that extra step. They often set up, like I said, ping, port, and protocol and process ID monitoring. But just because the process is still present on the server doesn't mean the process is healthy. So you should be looking at the application logs and looking for errors. And like I said, doing pattern matching on response strings. So oftentimes what I'll do is I'll encourage folks to create like a health.html page or a health.aspx or health.jsp if you're using Java servlet pages for your website. So you're actually architecting a monitoring endpoint, and then you're building some functionality into that dynamic page, which then, like I said, queries maybe today's date out of the back end on a database just to prove that that connectivity is there, the response time hasn't gone through the roof in terms of latency, and that your service is indeed better monitored in that regard. Performance monitoring is a more targeted area of monitoring. It's measuring the actual timing and response of all sorts of steps and processes in the middle of an application workflow. And the services, and it's not just monitoring what might be called up-down status, red light, green light monitoring. You much rather have some pretty pictures like here, on this graph that show when thresholds are being violated. So the first set of performance metrics defines the performance experienced by end users of the application. One example of performance is average response time under peak load. The components of the set include load and response times. The second set of performance metrics measures the computational resources used by the application for the load, indicating whether there is adequate capacity to support the current load, as well as possible locations of a performance bottleneck. So if I pull away my notes here for a second, you can see that this is, I think, a New Relic graph that I pulled off of the internet. And it's showing average response time. Now, obviously, you see sort of this spike and plateau for the response time, reaching what looks to be about 1,000 milliseconds, which would be a 1-second response time, which is really bad for something that's normally responding, around 200, 250 milliseconds. And so you're looking at the throughput and the average response time in one graph. And you can see this sort of light red colored area is when the threshold has been violated. Below that, you see an AppDex score, which is showing everything's good except for during that period. So it's kind of the inverse graph of the one above it. The error rate hasn't actually changed a lot in the third column, the bottom of the first column, the third row. But what's interesting over here on the right is you can see CPU utilization is also not constrained. It's alarming. It's gone outside of its normal band of 2%, but it's only gone up to 4%. So this is not a CPU problem, like a race condition. And of course, physical memory utilization shows that there's nothing actually happening there. The amount of memory being utilized by the app is entirely consistent during this test period. I think this is like April 9th and 1:10, 1:30 p.m. until 4 p.m. So the physical memory rules out a memory leak, right, or a race condition that led to a memory leak that caused it to exhaust the available memory. So it's using about 200 megs, which is almost nothing on a server or process these days. But the real culprit here shows up in the database graph in the lower right-hand corner. So you're looking at your database response time, and utilization of the database. So databases, when they get busy, they can definitely introduce latency, which caused, like a 4x increase in response times. So nothing crashed here. But anyway, you can use multiple monitoring and instrumentation of various checks to zero in on what's the cause. And then you can page the database administrator instead of the application developer, to come in and take a look at why did database, response time spike from, what looks like maybe 2 or 3%, utilization all the way up to, maybe 15, 17%. Here I have a picture that I pulled down from the Vodafone McLaren Mercedes graph of their performance monitoring. They have a lot of telemetry coming off of Formula One cars. And this dashboard is, I think it's created by, I want to say, let me double check. I think it maybe says in the corner, yeah, SAP. And so SAP is helping them, create a dashboard that demonstrates big data in real time to make predictions that actually inform the racing team. And so you can see a little bit of the track, and you can look at all sorts of metrics that are coming in. So this one's obviously a pretty sexy, racing race car dashboard in terms of fuel and engine and throttle and laps and all sorts of things that are being monitored. I think there's thousands of sensors on Formula One cars these days. All right, and then lastly, of course, the mainstay of why we work in this field and things that we should do to make things healthy is to have good security monitoring. Continuous security monitoring solutions provide real-time visibility into the security posture, constantly monitoring for cyber threats and security misconfigurations. You can only manage, though, what you can observe and measure. So if you don't have good monitoring instrumented, you likely don't have good visibility into your security posture. Security monitoring needs to be instrumented by application developers, but also by infrastructure teams to look at the disk latency on storage arrays, and of course by operations engineers, folks that actually support the alerts in infrastructure. They need to also work with the InfoSec team to make sure that various security conditions are tagged and alerted on appropriately. Take, for example, a web server authentication for a login page. If somebody's trying to brute force an account and you don't have automatic lockout on failed logins, someone could continue to try, for hours and days at a time, throwing breach data sets, right? Breach username, credentials, and passwords that come off of the dark web, for example. These can be, used to brute force and figure out how to get in, with those credentials. And if you don't have monitoring set up to sort of alert on variations in the number of 403 response codes, if you're familiar with HTTPD, the hypertext protocol daemons that make up web servers, there's a series of status codes that are used. Service status code response 200 means the server is okay. A request from a web client was made and the server was able to deliver it, no problem. A 404 you may have heard of course, which is a page not found. And then there's status codes that are used for server errors and server failures. Those are the 500 class errors. So 500, 501, 503. But there's a particular 400 error, which is a user client error called a 403, which means permission denied, or 401, authentication required. If you suddenly saw like 20,000 403s come in the space of a few minutes, from a particularly aggressive, third-party source, hitting your API or even hitting your web page, a security officer is going to want to know when that happens. So the application monitoring team and the SREs and the DevOps may not actually be too concerned about the quantity and the rate at which certain error messages are happening, because they say, well, a 403 is a natural response to a failed login. Why should we wake anyone up? Well, the theory, and not really the theory, but also the practice is, let's say that you had, 50 failed logins from a particular IP address with a particular username, and you had 50 403s that were suddenly followed by a success, right? By a 200. That's an actual dynamic monitoring threshold that you can set up and figure out how many successive failures followed by a success you believe is suspicious or unwarranted, which means they may have lit upon or found the right permutation of that password that was being used. Because a lot of people use passwords and just change out one character from rotation to rotation, from one to the other. And anyway, so you can detect this kind of behavior, and you can write rules that say, wake someone up if a particular sequence happens. Oftentimes, it could be as sensitive as five failed logins within a certain time frame for a particular user, followed by a success, could be considered a security event, a security breach. And so if somebody, fat fingers or mistypes their password once or twice, that's fine. But 5 times, you either lock them out or you set up an alert that sends an alarm. I have to have some more water, just a second. Okay, so what you see here is a map that doesn't exist anymore, but it was kind of like a pew, 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 pew map. It was from Norse Corp, and they had this Norse Viking map, and it was real-time threats and attacks and targets and protocols that are being used, and countries that are launching the attacks and the direction of them. And there's plenty of other ones that have survived. The Norse map has gone away. I think that there's a link actually on their page that I have in the slide notes, which then shows other kinds of net maps that still exist. Actually, it's probably worth to just spend a quick minute taking a look at that. So let's look at some of the top maps real quick that the Norse.com. So they don't operate it anymore, but they do have some links that we can look at real quick. So what is a cyber attack map? Could just be DDoS attacks, or it could be specific ones. Some of the most popular cyber attack maps, Arbor Networks has one. They do DDoS mitigations around the world, and so they have a nice map that shows who's attacking who. Kaspersky has a cyber map and a DDoS real time. This one's fun if you pull it up. Is this the real map? No, this is just a JPEG. Where's the actual map? Here we go, Kaspersky cyber map. Okay, so it's kind of mesmerizing, right? To be able to watch and to be able to pan around and see what type of attacks are in play and who's launching them and where they're coming from. And of course, you can zoom in and you can see all sorts of fun visuals. This isn't necessarily something that you're going to put up other than when the executives come around, right? And you want to impress them and show them they have your pew pew map going on, and see where your data centers are, and who's launching the attacks and who's being attacked. Let's see what these ones are, for example, over here on China. Oops, sorry, a little bit sensitive scrolling. Yeah, this looks like, no, that's not able to zoom in. And then let's see, what else can you do? Statistics, detections per second. I think this will take a minute to load. Several hundred detections per second. What are some of the data sources? On access scans, on demand scans, mail antivirus events, intrusion detection scans. And then I think they have a widget here that you can actually embed this map. And so someone would maybe put this up, in a security operations center, and then maybe filter it to your specific IP addresses. I think you can change the width a bit and make it wider, so it doesn't look scrunched. And then you could do dark or light, depending on how you want to display the information. And then you could do dynamic or static, and then send this code and embed it, in a view, so that when the investors come around and look at your security operations center, you can show them this lovely threat intelligence map. Let's see, there's also a demo mode in here, and you can toggle the color or switch to planar view instead of the demo one. I think is just sort of, a rotating image. One of the other ones that they had on here is probably worth taking a look at as well. Threat Cloud, they have a map Also similar kind of a feel. What kind of monitoring is going on? Recent daily attacks. It looks like there was a nice spike recently. And if you wanted to change some of the countries you're looking at, these are the top targeted countries at the moment. Phishing versus malware, different malware types coming in from bots. This one's powered by Checkpoint technology on the back end. If we want to look at just botnet, no, you can't filter on that. What can you do here? Current rates, allow interaction. Anyway, so pew maps, right? People like those. Let's move back to the slides then. Let's see, Chrome presentation view, no. I guess actually this one, and then share, and then go back to presentation mode. And just double check and make sure, yeah, this is the correct slide. Okay, and then I can pull up my notes again. All right, next up, let's talk a little bit about security orchestration and automated response. SOAR apps are software programs that allow an organization to collect data about security threats from multiple sources and to respond automatically to low-level security events without human assistance. A typical SOAR setup might be virus detection. So in this case, it's a really clear-cut use of SOAR because if a human is getting the alert, what's the first thing they're going to do with the virus detection, right? Well, they're going to want to isolate the device, right, and put shields up around it. Whether you do that from the network, from the agent itself, that could be running on the endpoint, the antivirus agent. It could potentially shut down all network traffic locally, or it could be something that communicates to the network uplink. Let's say it's a workstation or even a server in a data center. It could be that the network switch port will get disabled for that device, which would be even more restrictive because the bad guys are good at disabling agents, right? And if it's agent-based isolation, they could potentially kill the agent and reestablish network connection to the rest of your network and begin its infection, right? And its virus spread. So it's oftentimes better, in my mind, to have it communicate to a higher level authority, like a network access control infrastructure that would then trigger network isolation and disable the switch port and initiate a full, scan, right? If it quarantined a file that showed up, you could potentially want to isolate the machine and initiate a full scan. Why wait for an on-call engineer to start those steps? SOAR solutions are supposed to be triggered by that endpoint and then talk to other tools in your application stack, in your security tools to help bring that into play, right? Other scenarios, you may want it to go all the way up to a decision point and then have someone in a SOC in a 24/7 capacity review and decide whether to engage the next step of mitigation or not. Now, like I mentioned, the simple scenario to demonstrate the value of a SOAR solution is virus detection. Your laptop has an agent running on it. Let's say you clicked on an email from a business partner and that their account was compromised and they're sending you a Word document, but it has a virus embedded in it and you don't know this yet. The antivirus agent detects the signature or the behavior of the virus, and then when the Word document is opened, it quarantines the file and deletes it. The SOAR platform then engages based on this alert, and it isolates the laptop on the network, initiates a full scan. It could also then go further and trigger a query to your email platform to see if that same attachment was sent to anyone else, right? Maybe someone that hasn't logged in yet or someone that hasn't downloaded the file. And see if it was sent to other users. And it can actually proactively remove that message that might have gone to some of your colleagues as well from that business email compromised third-party account before it can be opened by someone else. And then it could also then go even further and open a ticket to document the incident. And then it could notify the SOC. And that can then signal the InfoSec team to reach out to the business partner and in case they're not aware of the compromise. So obviously there's 2-3 steps of automation that are occurring here, and that's what a SOAR solution is meant to do, to help you do that as quickly as possible. You may recall that the global threat report from CrowdStrike 2019 indicated that the Russian APTs are able to move laterally within 18 minutes. And if you have like a 20-minute on-call rotation acknowledgement schedule, the on-call person may not have actually seen the alert yet, and they've already started, moving laterally. And so I think it's important to note that SOAR, helps you battle this sort of escalation of response time. You don't necessarily want to then go ahead and shut down all the file shares and stop a ransomware from hitting file shares, because those could be false positives sometimes. And so that's where the human intervention, you have to decide where the automation should pause and wait for someone to take a decision before it continues and moves on. What you see here is an example of a screenshot that I took from Splunk. Splunk bought a tool called Phantom, which is a SOAR solution. And Splunk purchased Phantom for about $350 million in the spring of 2018. Phantom is a SOAR solution that helps organizations improve the efficiency of their SOC, as I mentioned, by automating certain tasks, orchestrating certain multi-application workflows, improving collaboration, and enabling incident response at what we call machine speed, right? Not human speed. There are several such solutions in the market, but I've seen this one 2 years ago at Splunk's live conference here in New York, and believe it's to be one of the market leaders in this space. That's one of the reasons why Splunk bought them. What you see here is this playbook editor that actually orchestrates the response to a phishing email incident. And so I think it's probably sending, you can't read this, but it's probably sending the artifact up to VirusTotal to get a whole bunch of decisions as to whether the attachment is detected as malicious in other places, and it's helping contribute indicated compromise and MD5 hashes of that malware file to the rest of the world. And so you're participating in information sharing and helping out here as well. And what's interesting to note is that this is a Python playbook editor, but you're not writing any code here, right? You can drill down and look at the code view potentially, but these playbooks are great because you can download them from a community, right? And not have to invent them yourselves. You may need to tweak them and say, well, we're not using VirusTotal, we're using Cisco's Threat and Talos Intelligence Center or something like that. But you can just basically drag and drop different interfaces into this and put decision trees, as you see in here, these diamond triangles, to decide what to do if something's true or false, and then move and say it could hunt for the file to make sure it's nowhere else. It can go and do some attribution research to figure out where this file came from and who's potentially the threat actor attacking you. It can also talk to other tools to open up an incident in your case management tool and software, all sorts of stuff. Jump into the email platform and delete other people's emails that have the same attachment. Anyway, so Splunk and SOAR, other solutions. I think Demisto is one that Palo Alto has written, which also plugs into Splunk actually. So a lot of these security vendors need to learn and are learning to play nice with each other and to not try to eat each other's lunch as aggressively as they have tried in the past, and to not try to be one solution that solves all problems, but to instead be a part of a federated set of tools that all speak to one another and that can be orchestrated successfully. All right, next up, application testing. Like many of the topics that we reviewed in this course, application testing could warrant a class of its own. I won't even be able to go into all the forms of application testing today, but rather discuss just a few of them. DevSecOps pipeline. This is a slide from a leadership forum session presented by Derek Evans, who may still be, but was at the time, director of DevOps for Pershing, which is a Bank of New York Mellon company, in May of 2019. He shared his view of how several scanning tools fit into their CI/CD pipeline. So what's shown here is SonarQube, NexusIQ, and Veracode. Many times, banks at least, can afford to have several tools that do the same thing, but you want them to perform the task at different points, and you want them to cross-check each other. So in this case, Veracode looks like it's doing tests between dev, test, and QA. And then earlier in the process is when SonarQube is having at it. SonarQube's looking at things like code smells, bugs, and also some security things like OWASP, top 10 violations. Then you have your build and unit test. And then you have NexusIQ in there, which is looking at approved open source packages and making sure that your code is only using the latest stable, secure version of Tomcat or jQuery or other types of packages that are part of a modern application stack. And of course, this is PCI, NYDFS, FINRA, and ISO 27001 required for them to have all of this information and to automate it and to open up JIRA tickets when things fail scans. This is one of the things that makes DevSecOps a thing, is that you have security engineers treating infrastructure as code and doing automated scanning. Let's see, he shared this slide on a view of how some of their tools fit together. This represents 3 years of DevOps transformation at the bank, at Pershing Bank. He moved from 300 apps that were being parsed and analyzed using HP Fortify to this particular setup. And I don't think Fortify is in this stack anymore. And now he was able to move from a 2-week reporting and analysis turnaround time and remediation to just 5 days. So that's one aspect of DevSecOps, is obviously automating things and removing barriers to speed and agility. This was also deployed self-service into the development environment. So developers can constantly iterate there, and they don't need a security officer to help them. But once it reaches the test environment, it actually has to pass certain build tests with at least 80% code coverage. So if you don't have test scripts written for 80% of the functions of your code, SonarQube is going to fail you, or Veracode is going to fail you, or Nexus IQ is going to fail you, because you can define these thresholds as to when it would let the code through, or when it'll open up a ticket and say this is blocked until this package is updated and this bit of code, stupidity is removed. And it's funny, actually, this perspective that he shared. He said that automation actually only helps you build bad software quickly if you don't actually put in gating controls, right? So you can imagine all this compression and speed is great, but if you don't actually put in quality controls and gating factors that actually block releases of code, you're just automating the release of bad software. You're not actually making the software better. And then in order to fund this, he got $1 million of budget from the engineering organization in his DevOps and InfoSec budget for developers to actually book their time against that $1 million cost code, and pay down out of that $1 million to pay down some of this technical debt and security bugs. Because a lot of times we run into the problem, developers are being asked to deliver features and functionality. They're not being asked to pay a lot of attention to non-functional things like security and availability. And so he found, and I wanted to pass this information on, that it's oftentimes very helpful, even if engineering had $1 million in its own budget to do this, if you put it into the InfoSec budget, then you can use a separate cost code for the developers to book their time against it. And then you can show an ROI, right? A return on investment. With $1 million spend across 300 apps that were taking 2 weeks to be reported on and moved forward, it can now be remediated and pushed out within 5 days. You're showing a velocity of release improvement, and you're showing the number of bugs and security vulnerabilities that are getting closed with that $1 million spend. This is the application security testing tools pyramid. This is from carnegiemellon.edu. They have a blog that has this graphic. I have the link in the slide notes for you that you can check later. But basically, I'm going to be talking about only 4 of these right now. You're talking about MAST, SAST, DAST, and SCA. So what are these acronyms? MAST is mobile application security testing. SAST is static application security testing. DAST is, of course, as you'd expect, dynamic application security testing, so runtime, vulnerability management and detection. Static is just looking at the source code, things like Nexus IQ. But there are other tools out there that do SAST, that do DAST. And then software composition analysis. I've worked in companies that can barely manage, monthly deployments, right? They're struggling to even do that. Others have reached weekly and minus a few holidays, and maybe change freezes. So if you do weekly deployments, that's 52 weeks a year, minus a couple of holidays, so maybe 48 releases a year, and that's not a lot, right? Whereas some cloud-native startups like Etsy are performing hundreds of deployments per day. So what does your business require? What can it tolerate? how much trusted automation and testing can you create? Because you can certainly leave the interesting work for the humans and let the machines and the scripts do all of the boring, repetitive work. So there's a sort of flow here as well: feature, source control, build, test, scan, and then deploy. If we move into some of the details of mobile application security testing, mobile apps actually have a unique set of requirements and security risks that have to be tested. They're not exactly the same as desktop and web-based apps. There's a company called Now Secure, capital N, capital S, no space, for mobile application security testing that integrates into Jira, for example, and it can be triggered from a post Git commit hook. Let's see, there are over 2 million apps in the Apple Store and Google Play Stores each. There are plenty of idiosyncrasies for developing, testing, and securing both iOS and Android. I often wonder whether people actually need native mobile apps, or if they should just move to using HTML5 and have responsive design that deals with the smaller real estate that's available on the screen for a mobile device. And that's a legitimate question, I think, to ask, because it's very expensive to have an Android and an Apple iOS development team. And of course, there are some frameworks that work across platform, but that in itself is also an expense, right, to be able to build cross-platform. So you may not be able to cut your mobile development team size in half to do the security testing if you're using one of those frameworks. You might be able to get maybe a 25% savings by switching to one of those frameworks, in my view. In MAST, you're looking for various aspects of source code analysis. You're looking at debug and static binaries. You're analyzing dynamic binaries. You're looking at attacks, interactive binaries. That's when you're inspecting, how it actually behaves in runtime, in real time, in memory, essentially, right? Not just the components of the software and the code. Source code debug is scanning, obviously, the source code for syntax errors and improper use of code pre-compilation. Static binary analysis is testing the binary post-compilation to discover vulnerabilities, including third-party libraries and supply chain attacks that can be introduced there as well. Dynamic binary attacks are directed at the actual binary device and network and the APIs at runtime. And you have what's called an outside-in perspective to find vulnerabilities. And then lastly, interactive binary inspection involves looking at the binary at runtime and collecting telemetry from the inside out, right? So you have an agent, potentially a New Relic or a Datadog agent that's deployed with your mobile app running on the mobile that's providing inside out perspective on vulnerabilities and strange behaviors there. In the space of mobile application security testing, you want to have test coverage for data in motion, data at rest, and of course, code quality. Data in motion, you have to pay attention to various attacks like man in the middle, certificate validation, SSL downgrade, certificate validity checks, cookie integrity. For data at rest, you're focusing on application files, log files. Does the application have access to an SD card in an Android phone, for example? What's happening with the usage of memory on the data on the mobile device? And what's called the secure enclave, or the trusted computing space on an iPhone, where your fingerprint or the digital equivalent of your fingerprint is stored, or your facial recognition pattern for your identity. Of course, in that enclave, you also may have a keychain, right, and various credential storage, cookies and tokens that have been pre-authorized to allow your banking app to be accessing your bank account. In the area of code quality, we're looking at things like bad authentication, bad authorization, because auth N and auth C are not the same. Again, auth N is a badge saying, this is me. It's an assertion of identity. And then auth Z is what doors can you open with that badge. And there's certainly lots of mistakes that are made in mobile application programming for authentication and authorization. You can also be using bad crypto. And in this case, bad crypto is crypto that's weak, crypto that can be broken easily, crypto that doesn't have a good salt to start the random seed for the basis of the encryption. And of course, you can have vulnerable third-party libraries. You can have path traversal. You can have SQL injection vulnerabilities. All sorts of code quality checks has to go into mobile app testing over and above what happens for just desktop and web-based apps. Let's see, what else? Mobile application security, no, static application security testing. So SAST. This is designed to analyze source code pre-compilation, right? And sometimes also compiled versions of code to help find security flaws. This is also known as white box testing of the code before it's been compiled. For Python, there's a particular tool that I want to show you actually called Bandit. It's an open source tool, and I'll do a quick demo of that. And then for a lot of us in the community space, we use SonarQube, SONARQUBE. They have a free community edition, which has limited functionality, but still quite useful. And then, of course, they have a commercial version. I've often made reference to Sonatype and Nexus IQ as a SAST solution that I'm a big proponent of. I've used it many times. I don't have any affiliation with them. I don't own stock or anything, but I definitely feel that I would be remiss if I didn't mention Sonatype and Nexus IQ, as well as Snyk, SNYK.io. And I'll do a quick demo and walkthrough of a couple of those for you here as well. Static application security testing, Bandit. Bandit was designed to find very common security issues in Python code. And so you can get Bandit installed by just using pip, right? You could do pip install Bandit and then do a bandit-r on your project folder. And so here's where I want to jump out to a demo and show you how Bandit behaves. So let's see, this is a good terminal to use. Let's share this terminal. All right, so I have a couple of code, maybe get larger, yeah. Make sure that's like readable for you if you're watching this back later. All right, so hopefully that's visible. So I'm going to go to my work directory. I have an alias called LGW, which basically just CDs to my work directory. And I already have Bandit, but if we had installed it, we would just do pip install Bandit or pip3 install if you're using Python 3. And it's in my user local directory. So I'm going to say bandit-r, and I've already checked out a tool called Hunt, which is a security tool. And I think I can open that up and show that to you. But basically, you'll just be able to see what happens when it scans it. So it's looking through the code, and it's pretty quick. It scanned, 1,300 lines of code, and it found one medium issue, and the confidence on that was high. And so the one medium issue was this one right here. So, and if we scroll up a little bit, we can see a little bit more of what it was doing. Yeah, not much actually output fell off of this screen. Good. So what does it say? It says there's a high confidence that this is a medium vulnerability, and it said blacklist calls. So there's certain calls that you shouldn't be doing, or certain methods in which you make calls to web pages. And it says that audit URL open for permitted schemes, and you don't want to make sure, or you do want to make sure that you have, you don't have the ability for someone to put in something into this response that's used to violate, the integrity of your code, right? Someone could inject some bad response data into the Hunt project, and it could potentially, like I said, break out. And so what it does is, whenever you have a vulnerability scanner, you need to be able to show the developer where to go to find out how to fix it. So let's switch to the full desktop share for a minute so I can just arbitrarily move from page to page. So let's look at that request. So basically, these are some of the URL open that are considered risky. And so the one that was listed here is what they would do. So it's basically a blacklisted Python call that are known to be dangerous. And there's probably a safer way for them to make the call to this API for Pearson.com, looking for a particular decoded parameter inside of this code for Hunt. Another one, bandit-r, cross-site strike is an open source InfoSec tool. And so I thought, okay, I'll download the latest version of it and see if it has any vulnerabilities in the Python code that Bandit can see. What came back? 9 lows, 7 highs, and the confidence on all of them was 6, was high. And so we can scroll a little bit through this list. It's a little more verbose. So obviously you want your security tools to be secure. You don't want them to introduce vulnerabilities. And so in this case, we have a test result. This one, I think, was considered, a low, right? with a high confidence. And it says starting a process with a shell seems safe, but it may be changed in the future. Consider rewriting without the shell. So it's oftentimes lazy that people start a shell to execute a certain command instead of using a library to do it. Because again, anything that opens up a shell could potentially be hijacked. But that one's fairly low. These blue ones are low. Let's see what else. This one says standard pseudo-random generators are not suitable for security and cryptographic purposes. And they're basically looking at like a random choice of user agents. Now, in this case, I don't think it's a big deal because this is a cross-site scripting testing tool that needs to simply pull randomly from a set of user agent headers to decide which one to use on a various test. And so this is one I would pass on this. There's no need to remediate this. You don't need cryptographically strong randomness in order to pick from a list of what user agents you're going to pretend to be impersonating, whether it's Microsoft Edge browser, Opera, Chrome, Safari, things like that. So that one can be ignored. Here's a high, and this one's interesting. It says requests call with verify equals false is essentially disabling SSL certificate checking, right? Not cool. You don't want to do that. Where is it doing this? It looks like it's making a request here, and it's just ignoring essentially whether or not the certificate matches. Now, obviously, for a testing tool, you don't want the testing tool to break just because someone used a self-signed cert, or the self-signed cert has a different name on it than the actual service that they're testing with. So in the case of this high, most code ought to leave verify to be true, right, for SSL requests. And if the certificate doesn't match, it should fail and say, hey, the certificate doesn't match. But in some testing cases, you are actually using, IP addresses instead of host names to do testing. And so if you turn off verify for the certificate validation, you would want to make sure that you're testing the certificates and the verification and credit revocation lists and CRLs, things like that. You're going to do that elsewhere. You may not want to actually do it within this tool. So this one could be potentially accepted as okay because you are doing sort of edge case scenarios in testing. But in general, it just gives you an idea of what Python bandit's coming back with. Unsafe practices, you decide whether or not you want to call that out on the code if you were the team that's writing cross-site scripting strike, this particular testing tool, or any code that you're running as a Lambda in AWS, for example. Looks like there's another code, another one popping in here for verify header is false. In this case, where is it headed? It's looking at various proxies and ignoring whatever's happening with the mismatch of the code. Here, this one's slightly different. This one says the input method in Python 2 will read from standard input and evaluate and run the resulting string as Python source code. So this is similar, though in many ways worse than using simply the eval statement. So if you've ever done software development, you know that this is a pretty scary thing to do, to just let someone provide some input and then it's going to run code. But again, if you're running a cross-site scripting testing feature, you may very well want to let that security tester enter in a little bit of Python to see what it does to the cross-site scripting functionality. And then here, I think this one was starting a process with a shell, possible injection detected security issue. In this case, they're doing a git clone and they're checking out the cross-site scripting app itself. So this is like a self-update function, right? You want to let it do it, but maybe you want it to be a little more secure than that, than to just have a hard-coded URL. Anyways, these are some examples of what Bandit can come back with. And it can parse and analyze code for you. You can automate this into your build process and make sure that anyone that's deploying Python code comes back with a list of vulnerabilities, right, for that. And this is certainly the case in what's called shift left, sorry, when you try to automate as much of your security functions as you can in the build pipeline so that when someone's working as a developer in a local sandbox instance, they're running the code and all sorts of security tests happen on it at that time. And they remediate these, right? And you can parse the output of this and you can fail the build or the run and put in a JIRA ticket before it reaches shared environments like QA or a shared UAT environment. And then, of course, by the time it reaches production, there should be none of these issues, right? Or someone should have signed off on them like I just kind of did. But you'd have to document which of these flags you're going to let through in cooperation and in communication with the developer, to make sure that they don't just sort of say, yeah, I'm allowed to do all sorts of unsafe coding practices in this build. So anyway, that's two examples of Bandit that I wanted to share with you. And you just basically point it at the folder that contains Python code, and it will then start working and figuring out. You'll start working and figuring out what pieces of code you want to be looking at. All right, so I think we should be back into the Bandit share, and I should be able to pull up the notes and continue some additional slides, the next slides. Yeah, so here was the demo of Bandit using the tool. All right, next up, static application security testing with a tool called SonarQube. Inspection of code quality, right? Not just security, but also just bugs and defects, to perform automatic reviews with static code analysis, like I said, bugs, code smells, security vulnerabilities on 20 plus different programming languages. This is a great open source platform, SonarQube. The community edition has limited functionality, whereas the enterprise edition contains everything that you could want. While the security engine is actually part of the enterprise edition, most organizations would purchase that edition anyway, just to get at the OWASP plugin module, where you can dynamically scan your code to figure out whether or not it violates any of the OWASP top 10. It's a really easy and inexpensive way to get that kind of code scanning and coverage, and built it in and automated so that as soon as a build for an app happens, it kicks off a SonarQube scan, it comes back with these results, and you set the thresholds as to how clean it has to be before it gets to move to the next level. Static application security testing Nexus IQ. So this is a policy engine that's powered by intelligence of open source components. Over 500 billion download requests of Java, NPM, PyPy, Ruby gems were recorded by Sonatype in 2018. So they know a lot about who is accessing what code. I think we've already included a couple of their reports in previous lectures, and so I won't go into those again. I didn't update this number. The 500 billion is probably 800 billion at this point, right? Because it's been 3 years since then. But what do some of these screens look like in Nexus IQ? So here's a scan that I did, and this is not the latest version of cross-site scripting strike, but basically I ran Nexus IQ scan of their GitHub code when I was evaluating Nexus IQ, and I can use the results to explain a little bit about how the tool works. So vulnerabilities are categorized by severity using CVSS, as you're familiar with our discussions before, and then details are provided for each vulnerability. So shown here is the security issues section of the report for cross-site scripting strike, SSX strike. An open source project that I just downloaded and scanned. So it shows that there's 10, severity or criticals, 18 that are severe, which have a CVSS of 4 to 6, and then 0 moderate, and a couple of in between, and 9 license alerts. And that's one thing that SonarQube does, or sorry, Sonatype does, that's really quite powerful. It's not only checking the whether you have the latest stable, secure version of a package that you're using in your code, but it can also check your compliance risk as to whether you're using a copyleft package, which would require you to make your product free. And so if you use any copyleft protected code, you're violating that copyleft license model by charging for your software. And someone can come after you if they figure out that you're using it. And so that's a legal risk and a finance risk. A financial risk. It can check, like I said, shown here, you can see that some of the libraries in the project are bringing some potential legal risk, but your organization actually gets to define and decide which open source license models are considered okay and which ones should be flagged as a risk. So in this case, there were 2 moderate license risk analysis and 2 severe and 7 moderate. And then 176 of the components all checked out as no threat at all. Those might be, an MIT license, a BSD license, an Apache license. These are different licensing models that are used for software. And then we can drill down a bit even further and look at some of the policy violations that went into cross-site scripting code. Here we're seeing the main section of the report that we want to look at, and this is what you want to share with the developers, is the policy violations, which identifies which libraries and components have CVEs that tell you what versions you should replace them with to get to the latest stable and secure versions. And they make it really easy for the developers. So this is what like an older Mac IDE plugin might look like for someone doing some coding. And it says, okay, the declared license for this struts framework is 2.0. The observed license is the BSD Apache hybrid license. And then there's several packages in here that need to be updated. So we're looking at Xwork core, for example. This one should be moved to the right. So if you click on those arrows down at the bottom, it'll eventually get you to a version that has no license risk. It's blue. It has no security alerts, and it's the most popular version. So they can actually provide this popularity graph based on how many times this version is downloaded from the Maven repository, which they operate on behalf of the Apache Foundation. They took that over several years ago, which is why Sonatype is one of those great tools, because they have billions of software vulnerability events and people doing uploads and downloads. So in this case, this version of Apache Struts 2.2.1.1 is not the latest stable and secure version. And so it'll recommend, and you can actually click on it and it'll actually do a pull request and merge the latest stable secure version for you. So that's enough about Sonatype. The other thing I wanted to do was talk about Sneak. Sneak is another tool in this area. It is a static application security testing tool. It looks at source code and source code coverage, and it helps developers find and fix vulnerabilities, right, in open source libraries and in containers. I actually started using this tool when I was working at Marvel, and when I volunteered for Disney's open source committee. So I put in a time, I think it was every week actually, and we would look at code and libraries that had been submitted to the open source committee for approval, and we evaluated Sneak, and it turned out to be it was awesome. And I really enjoy it. It's web-based. It can do command line, makes these pull requests really easy for the developers. Because anything you can do to make things more secure and easy is going to be a win-win. One of the things I liked most about the tool was the ease of integration with command line tools in our CI/CD pipeline and the test coverage for PHP as a language, because not everyone actually looks for and can find PHP vulnerabilities. And a lot of the Marvel application stack is actually built on PHP. I also appreciate the tool's ability to send an alert with an embedded pull merge request. And so it's almost like click and drool easy, right? The developer gets an email saying you have this outdated component, click here, and it already builds the package for you. Almost no thinking required on their part to make that happen. And it addresses the open source vulnerabilities or recently published for the components. And here it was worth the time to jump out to a short demo here as well. So let me see if I have the right link open, because if I remember correctly, I have to switch browsers for this because I'm using Firefox to talk to my Sneak. Let me see if I can copy that URL. All right, so I think I already signed in. Otherwise, you'd get challenged with a login page. So you see I'm already logged in as Wilkes. And you can see a bunch of projects that I've forked into my GitHub. So basically, you're pointing Sneak at your GitHub. And some of these ones I picked up actually when I was working at Marvel. And I would fork the project. JS Hint, for example, I think is one of them. And so let's just see how easy this is to use, right? So I have a copy of this project. So I don't want to go and try to change anyone else's project for them, right? So I fork it. And it shows me that I have 3 highs, 2 mediums, and 1 low for this particular piece. So I can jump in here and I can say, fix these vulnerabilities. And it says, okay, well, there's command injection vulnerability in one of the most popular NPM packages it's called Lodash. Everyone uses it, right? And so I can upgrade and fix these, right? These 3 highs and 2 mediums. And it's going to open up a fix pull request. So Sneak is talking to GitHub in the background and sending the pull request. So now I'm suddenly logged into GitHub, as you see up here in the location, right? And the pull request has been automatically created by the Sneak bot, right? And you have this great documentation and audit trail. The person can review it and say, okay, it's not a breaking change, so I'm pretty confident that the code will keep working after I update all of these packages. This one has a CVSS score of 9.8, right, for a particular vulnerability by Lodash. It'll be, there's no known exploit, but it's a high CVSS, right? And some of these have proof of concept maturity exploits out there. So basically, I just go down here and I say, okay, merge the pull request. And I say, okay, this is why I'm going from Lodash 417.12 to 417.21. And then it's going to send an email. I do the merge request. Pull request successfully merged and closed. So how easy was that, right, for a developer, and I'm not really a developer, right, to fix the vulnerabilities and security vulnerabilities. There's built-in tools in GitHub that do this as well, that could look at Dependabot alerts, but you have to enable it and you have to have a subscription that supports that. So Sneak let me do that for free. You can't maybe use it at an enterprise level with hundreds of users and hundreds of repos, and you can't touch private repos. Those were just public ones that I had branched and forked for educational purposes. But basically, these tools are totally amazing and awesome to help us do our job and make the world easier for developers to make their code safer. So let's switch back to the Chrome page. So that was 2 demos. Let's see, we're an hour and 15 minutes in. And we're on slide 40, looking good. So let's move on to the next topic. All right, dynamic application security testing. So unlike SaaS tools, DAS tools don't actually have to have access to the source code. And therefore, they detect, sorry, I'm going to sneeze. No, I'm not going to sneeze. I yawned instead. All right. So unlike SaaS tools, DAS tools do not have access to the source code. And so they detect vulnerabilities by actually performing attacks against your code. And this is what's called black box testing, right? Because you don't have access to the source code, so it's like an opaque black box. White box testing, as you might recall, was SaaS, right? Static application source code testing, where you're actually scanning the source code and finding out what's going on. In black box testing and in DAST, you don't get to know what's going on. And that's obviously the reason for the input and the output in the black box in the middle. So one of those tools in this category is checkmarks. This is an enterprise grade solution, but it does have a few limitations. Windows and MS SQL are the only installation options. So if you don't want to have any Windows servers on your infrastructure, you can't use checkmarks because checkmarks only runs on Windows. Now, that doesn't mean that it only checks Windows code. That's not true. It can do, static or dynamic code analysis of all sorts of code, of all sorts of binaries, because again, it's black box. It doesn't care what OS it was compiled on or what OS it runs on. It's just inspecting the compiled code, post compilation. And it's expensive. But that actually appeals to many organizations. It supports code scanning in 25 different languages. So this is checkmarks with an X. And if these restraints or limitations of it don't trouble you, and for most people it wouldn't, you can certainly use checkmarks. Another tool in this category is Fortify. And we had talked about that Bank of New York Mellon guy that moved from HP Fortify over to using Veracode, SonarQube, and Sonatype's Nexus IQ. But Micro Focus actually owns Fortify on demand now, and they deliver it application security as a service. And like I said, it used to be HP Fortify, but they sold it to Micro Focus in the fall of 2017. And a quick review of the pros and the cons of the tool indicate that it does not always provide developers with clear guidelines for what the developer should do in order to correct the problem. So how frustrating is that, right? You get an email as a developer and it says, there's something wrong with your code, but it doesn't tell you where to go next or what the violation was or how you can potentially fix it. That's the complete opposite of what we just saw with Sneak, right? Which was Sneak already prepared the fix for you, right? And just made it, green button click, and you're done. This means that the tool if you're using Fortify, is best supported with a fairly knowledgeable AppSec team that can provide that direction and guidance. So I'm not saying Fortify is no good or doesn't have a place, because it does. It is good and it does have a place, but it's a little less self-service and user-friendly in that regard. And lastly, we're going to talk about SCA tools, software composition analysis. So SCA tools generate an inventory report on all of the open source components in your products, and including all direct and transitive dependencies. So you could load one package that is part of your requirements for building Python code or C# or any type of language, PHP. And then that package could have a dependency, right? So you have second and third degree dependencies. One funny example, rounded edges for a box that is going to be drawn on a web page. If you want to implement rounded edges for your dialog boxes, that can actually cause an NPM list, right? A node package manager for Node.js to include several hundred packages just to achieve rounded edges on a dialog box on a web page. And the distinction I should point out between the offers of DAST, SAST, and SCA, they are actually blurring a bit over time as each platform and solution begins to offer what you might call adjacent service offerings, whether this is by acquisition or by demand for business growth. So you might think SCA is not much different from what Snyk was doing, right? Because Snyk was looking at all of your open source package components and suggesting which ones should be the latest ones. And DAST is going to potentially find some of these vulnerabilities as well. The line between DAST and SAST is a little bit stronger, but the line between SAST and SCA, that one's blurring a bit, as I mentioned. In the space of software composition analysis, we also have a vendor called Veracode. Veracode provides an automated cloud-based service for securing web, mobile, and third-party enterprise apps. Veracode was founded in Boston in 2006. The company was purchased by Computer Associates in 2017, which was then purchased by Broadcom in the summer of 2018. And when the acquisition completed in the fall, a private equity firm in San Francisco named Thoma Bravo bought Veracode from Broadcom for $950 million in cash. Although this might trouble someone who looks for stability in their vendor portfolio, the fact that Veracode is essentially a fish that's worth eating and worth eating multiple times over several years means that there is value to the product and to the platform. So Veracode still operates at veracode.com, but now it is owned by a private equity firm. So anyway, it's basically your invoices for your Veracode bill. If you've purchased them back in 2016 and have been using them for the last 5 years, you've gone from like 3 or 4 different billing invoice addresses that are coming at you as the acquisition of the code and the product has changed over time. OWASP Top 10, can't talk about application testing without it. SonarQube was a great way to implement that, but if you buy the Enterprise Security Engine, not just the Community Edition, OWASP Top 10 has a list, and you should be familiar with it by now. If not, we can potentially look at their website. But basically, it's not hard to find, and everyone assumes that everyone is doing it, right? Making sure their code is not violating OWASP Top 10. And that includes these items, right? SQL injection, code injection, broken auth, sensitive data exposure, insufficient logging and monitoring, right? These are basic ways in which people can do a bad job of writing software and implementing infrastructure and providing services. And the strange thing is that the OWASP Top 10 hasn't changed much in the last 8 years. You'd think we'd get better and some items would fall off of the top 10, or at least wouldn't be in the same slots every year, but they don't. And the Open Web Application Security Project, that's what OWASP stands for, is a nonprofit foundation that works to improve the security of software. Through community-led open source software projects, hundreds of local chapters worldwide, tens of thousands of members, and leading education and training conferences, the OWASP Foundation is a great source for developers and technologists to help secure the web. So if you've not played around with OWASP and you're working in the space of InfoSec, you're doing something wrong, because OWASP is a part of all of our lives. All right, so now it's time to talk a little bit about pen testing. Penetration testing, colloquially known as a pen test or ethical hacking, is an authorized simulated cyber attack on a computer system performed to evaluate the security of that system. Challenges faced by pen testers? Well, they need to determine things about session state management, as it's not done consistently from one application and one developer to another. Pen testers have to figure out how to parse the scripts and the code that a site depends on. And there's lots of language diversity there used to generate that code. So pen testing is challenged by the diversity of programming languages and implementation techniques. And of course, it's challenged by the degree of obfuscation that might have been applied to the code. They need to intuit what the business logic is going on behind the process that they're pen testing. And it's a very iterative activity, right? A pen tester can maybe launch a couple of scripts to begin with, just to kind of get a lay of the land and do a spidering and crawling of the site and figure out what types of code and headers come back. But really, it's an art. It's not a pure science. URL parameters are very customized from one website to another. And oftentimes we're pen testing web-based applications because they're internet facing and therefore they have a higher risk profile. If you have an internal app that's never visible to the internet, you might want to do pen testing on it, but you may not need to do the same level of checks because you have a model that says, well, it's not exposed to random bad guys. But remember, there are bad guys on the inside of the networks as well. We have to assume that the bad guys have access to your platform. So just because something is on the intranet and not the internet, the intranet being some web portal that you might run inside where people could do customer service queries and figure out what the account balance is with some of the clients to do Salesforce type work and things like that. These URL parameters are targets of bad guys as well that could potentially compromise an endpoint and attack you from the inside out. Anyway, so those pen testing activities largely focused on internet facing. Various URL parameters are often customized and non-standard. And of course, there's also fragile apps out there, and pen testers can make them fall over. And so a lot of times the rules of engagement for pen testing, and one of the reasons why we had an agreement as to how far we'll go with your scanning for your student assessment projects, was because there are fragile applications, I'm sure, within NYU. And a lot of them all just fall over if you look at them funny. So pen testers have to get agreement as to what they're allowed to look at and what they're not, and how far they're allowed to go, right? Achieve remote shell, insert a web shell on a web server or on a Microsoft Exchange server. All sorts of things should be very explicit, because pen testers can actually end up in jail if they don't have very clear rules of engagement, because they are potentially breaking the law in their function as a tester. Penetration testing. Remember, you want really, really good advanced pre-engagement discussions. You want to have a reconnaissance phase of the pen testing. Then you're going to have threat modeling and vulnerability discussions as a pen test team. You're going to identify what you're going to go after, what you think will yield the results of your engagement, and the sort of what are they called, prized targets. And then, of course, there's the exploitation phase where you actually try to take over which vulnerabilities you think you can have a tool to break into. And then post-exploitation, what types of activities you do after you break in. Let's say you send a phishing email. Obviously, a lot of penetration testing and red team exercises involve trying to phish various credentials or land malware on the platform, and maybe the person doesn't have the latest malware definitions. Maybe they don't have any malware or antivirus on their machine at all. That makes a pen testing exercise a lot easier, and then they can move through the infrastructure and find out what to do after they've done their preliminary exploits. And then lastly comes the reporting phase of a pen test, where you report back to the organization how you did the hack, and what tools and techniques were used, and report back. And obviously they're supposed to close them down then once they learn about it. Kali Linux, the Metasploit framework. There's outsourced third-party vendors. You can keep it in-house. If you're Visa or MasterCard, you probably do so much pen testing because of the value of your targets and the risk that you likely have a very large internal pen testing team, which is not to say that you wouldn't outsource some additional testing, because your internal pen testers could get kind of complacent and biased just through repetition, and they could forget to take a sort of outside the box thinking approach to it. So oftentimes people will engage a company like HackerOne to do a bug bounty program. And that way you're paying people to find, clever exploits to the code, like Visa and MasterCard in their business logic, things that can't be found just by doing vulnerability scans and SAST and DAST and MAST and SCA. These bug bounty programs usually have quite the good return on investment. And there's a lot of good, expensive bounties that are paid out. I remember hearing at a HackerOne dinner that I went to in New York a couple of years ago, vendors always try to tell you what they're doing and lure you with a good steak dinner, right? And so I've taken them up on that. That's how I stay abreast of things. They may as well pay for my dinner. If I don't go, someone else will. HackerOne had a lovely one. And there was someone talking about some of the best hackers in HackerOne earn a six-figure income from doing this bug bounty testing. Pen testing. Let's walk through some of the phases of pen testing. Pre-engagement. So whether you're working with a third party or performing pen tests yourself, the ROE, the rules of engagement, need to be agreed. Otherwise, someone might go to jail. And that's not an empty threat. That's real. Sometimes red team tests involve physically breaking into the offices, of a government building or something. And if you don't tell them and have a safe word that they can give, to the security guards who might catch them, then those folks could potentially go to jail. And that would be bad. You don't want to go to jail for doing your job. Pen testing tools are hacking tools, and there are laws and rules about this. Shown here are the rules of engagement for performing penetration testing of Microsoft Azure and its affiliated cloud services and applications. So Microsoft's gotten pretty advanced, pretty quick about this. They have a web page, you fill it out, you say when you're going to test so that they can at least have like a friendly fire indicator to stop their intrusion detection system from going ballistic and trying to figure out who's hacking them or attempting to hack them. Because you are running your platform in Azure. Microsoft has this very, like I said, easy self-service, log into a web page, state who's doing the testing, what IP addresses they're coming from, and that takes care of it. Other places you have to get much more explicit agreement, whether you're checking something on AWS or Oracle Cloud or in Google Cloud. It's a little bit more involved. Typically, your third-party pen testing agencies are going to be all over this, right? They're going to know which ones have easy ways of declaring a test and getting approval for it, and which ones take longer before you can actually schedule the test. In the reconnaissance phase, now that you've kind of agreed what the rules of engagement are, this is mostly going to be people-based, right? This is the weakest link in every organization, and the reason that phishing and social engineering are often all that's required in pen testing. There are plenty of tools out there to enumerate the employees of an organization, but few are as rich as a source of information as LinkedIn. So using API tools that are meant for recruiters, you can harvest the entire org chart and management teams with just this one source. Combine that with a few posted job descriptions, and you can come up with a very plausible email scenarios for building up your knowledge of the company and phishing email tests, right? All of its vendors, what the entire application stack is made out of, because the job descriptions often say, we need someone that knows AngularJS. We need somebody that knows, Office 365 and so they're explicitly declaring what their application stack is. And so reconnaissance is going to be used in pen testing and by the bad guys to look for those things and to find what the likely vulnerabilities are. This is easy to do even before you're pointing an actual vulnerability scanner at the public IP address ranges of your pen test target. Another area of reconnaissance that I mentioned over a year ago when I first taught this course was securityscorecard.com. And little did I know at that time that I would now be the CISO of Security Scorecard. But such as it may, there's no reason for me to take it out. It's a valuable platform. I know even more about it now than I did when I used it in the past at Marvel and ASCAP. And it bears mentioning, and you all get to use the platform. If you haven't already, check in with me, because the credentials are in the GitHub repo, and you can log in and run the reports and make sure that you use that to augment your security assessment data. Security Scorecard leads the new Forrester category of cybersecurity risk rating solutions. So we're in the upper right-hand corner of the Forrester Wave report. We're beating out all of our customers. all of our competitors. We're supporting all of our customers. And we've recently moved to over 4 million rated companies. That used to be 1.7 million, 2 million a little while ago, and we've doubled that recently by expanding our growth. So using only publicly available information, Security Scorecard is in the business of helping you manage your vendor security risk by providing an A through F score to help you and your third-party vendors understand your security posture. Like I said, I've used this platform for several years, and I have to say it's one of the easiest investments an InfoSec program can make. The ROI was very easy for me to demonstrate because you might be paying an InfoSec analyst $150 an hour to collect this kind of information by hand. Purchasing this information is essentially outsourcing it for a fraction of the cost, and you get the entire internet scanned at your beck and call. Penetration testing reconnaissance, right? This is an example of an executive summary for NYU, showing where NYU is at or below industry average for universities. Very simple spider chart here, for example. Another one then is a comparison report, right? What is NYU's arch rival but Columbia? And when I ran this before, I think they're both scores have changed since then. But when I ran this before, NYU had an overall score of a C, a 74, and Columbia had a D, a score of a 68. And this is sort of gamification, right? Of you could do Coke versus Pepsi. You could do the Chicago Bears NFL team against the Green Bay Packers. Take basic rivalries and throw them into the platform and do a comparison report and see. And you can see which ones they're stronger and worse on. So it's like a different shaped risk. And of course, these things change over time, which is why it's useful to have continuous monitoring and to be able to see this information on a daily basis and not just once a year. And so as I've done in previous offerings of the course, I'm going to jump out to a quick demo of Security Scorecard in case you haven't seen it yet. So let me go full page on this one just to make sure we're looking at the right thing. And we go here to platform.securityscorecard. I pull up my password vault. I use my NYU creds to log in. And so we get to see what the platform looks like these days. So the dashboard, you can go to scorecards and you look at my scorecard. So NYU has dropped since that last snapshot that I've made. They're now at a 60, which is not cool. I need to help them with that. I feel responsible for helping them with their score because I have this great insight as to what is going to lead to a breach for the university. And there's just thousands of findings in here. Typically, the history is a good place to start telling the story, to look at the last 12 months history for the scorecard. And we can see that the score has been going down, right? It used to be in the 70s back when I had taken that snapshot, and it's just been slowly going down over time. And so this is a pattern, that's going to lead to a breach. We actually have breach events and incidents in here. There hasn't been one since 2017. That is, if you view the report, it opens up that portal here, which is Health and Human Services, actually. They have a breach report, and there's probably an NYU entry on here. NYU, maybe not. We'd have to find it another time. It might be in the archive. It may not be. Yeah, these are all breaches in the last 24 months. And the one we were talking about was from 2017. But anyway, so this is a list of issues. There's a whole bunch of content security policies missing. Outdated operating systems are observed. How is this information gathered if there's no agent running on the inside, right, of NYU? This information is gathered through buying ad market data. So when someone's browsing CNN.com or Home Depot, we can see the IP address of the browser because that's in the log files. And we can see that it's running, Windows NT 6.1, which is Windows 7 as a product name. And that's been end of life, end of service for a while. It was last seen on April 8th coming from this IP address, which is within the network of the NYU. And so this could be a student computer running Windows 7. So there's a little bit of a problem with attribution when you have a large university or a large cloud service provider, or even if you have a guest Wi-Fi. But we understand this, and we make it possible for people, Security Scorecard makes it possible for people to submit a resolution. So you can click on this button here, you can say resolve, and you can then come up with an answer, right? And the answers that you can say are, I fixed this, I have a compensating control, or you can disavow the attribution and say, this is not my IP or domain. And then you put in some information, and we'll either accept or reject that assertion that it's dealt with. And these are the different ports that were used. But anyway, so there's a bunch of Windows 7 machines, that may well be university infrastructure that hasn't been upgraded. And if you talk to the global CISO for NYU, Maria Suarez, she may be well aware that there's still a bunch of OS upgrades that need to be performed. Or a lot of these could be, like you said, student machines that are running Windows 7. And there's nothing the university can do about it because they can't force students to run the latest OS. But anyway, that's one of the issues or findings that's available here. Malware infections, these ones come from our sinkhole data. I think I'd mentioned that we get something like 700 million events a day. There's an Android vulnerability coming in, 27 observations through this source IP, most recently seen April 8th, so quite recently. Here's another one, the Z-loader. It hit our sinkhole coming from this address. And if people say, well, how do you know this is our IP? You can click on it and you can look at it, and it shows up in NYU's network range, essentially. If you do a full source, you can show that this network range is starting from 128.122. Looks like it's a /B or class B network. And so it includes the range of this particular IP that we saw, 128.122.77.39. But if we want to go back to the digital footprint, this is all of the IPs that are a part of NYU's digital footprint. So if we look at the summary, we can say there's 243,000 addresses that have been attributed to NYU. And some of these map, to Singapore, Arab Emirates, for the Dubai campus, and other places as well. And you can always download it as a CSV and discuss it with the network team to see if these are correct. What else is interesting about NYU scorecard? So we did endpoint security, application security. This one's pretty straightforward. There are some, maybe patching cadence is actually better. So 27,000 findings in here under patching cadence. So here's 3,000 findings related to high severity vulnerabilities that were observed on the network. So OpenSSH versions are not looking good. This is from 2010, the version that was detected in the CVE for it. It was last observed by our scanners on April 8th, which I think is probably the effective date. We're about 2 days behind real time when we publish these. And it's on this IP, and this is just the first 500, but you can download the whole CSV. And any company can do this and use this to figure out where their vulnerabilities are. The last thing I'd want to mention real quick in this demo, or maybe not real quick, but at least mention, is that there's all these cybersecurity frameworks that you can then use. So let's say that some of these IP addresses need to be HIPAA compliant, or some of these IP addresses need to be NIST or 800/171 or NIST 800/53. So you can select that framework, and then it shows all of the findings that trigger violations of that framework, right? So this is a really good compliance and automation tool to help figure out which of these findings have a related issue. So if we scroll down a bit, sometimes they're harder to find. We had a couple of them right up at the top, but usually there's a couple more that come down about halfway through. Let's see if I can find one here. Which issues violate various NIST controls? Come on, there we go. So CA5, right? This is under the organization develops a plan of action and milestones for the information system to document the organization's planned remedial actions. Supplemental guidance, plans of action, what else? OMB, member. Anyway, so there's 3,000 here, 10,000 mediums, 1,000 lows, additional vulnerability findings as well. Some of these are fairly duplicative. But anyway, so there's all sorts of frameworks. that can be applied and to help people raise their score. And there's a scorecard planner as well. If you click on improve your score, if you want to get to a C, you can say, okay, generate a plan. And so now it's going to say, okay, what's the biggest bang for your buck, right? What should you work on first? How do you get your score to a C? And then from there, get it to a B. And then from there, get it to an A. So definitely go after these open DNS resolvers, right? This is, if you remediate it, your score is going to go up by 0.3. Then go after the outdated operating systems, right? That'll go up by 7.7. Get rid of those Windows 7 machines, those 7,000 vulnerabilities. If they stop showing up, in the ad data coming from the NYU networks, then the score will go up by 7 points. Get rid of these malware infections, track them down, right? And so it gives you a whole plan on how to start this, and you can download the plan. You can adjust the plan and decide that you want to go to, take some of these items off the list and figure out how to get your score, because you can't resolve this one. In this case, what would be outdated web browser operating system. So let's say we take this one off because we know we can't do it. Score plan. Where's the remove? Maybe you can move it down. I'll have to double check on exactly how you change your plan. But anyway, so that's a little bit about security scorecard, and you can build your own custom portfolios. You can go to, what would be an example, portfolios, right? So you can create a new portfolio and you can say nursing school, right? And then you can add used for vendors that deliver services to the school, and just call it Nursing Space School. And we can make this a company rather than private shared to me. So everyone that has a login to NYU's scorecard can see it. We can add a company, and we can say, well, I don't know, what would be something that nursing school depends on. They probably rely on box.com for file transfers. A lot of the university does. So you can add box.com to the nursing school portfolio. It's now there. If you want to add another company that the nursing portfolio uses, you can look it up. And that's why it's helpful that we have 4 million rated companies here, right? That you can find them and it's instantly available. Nursing probably has, what would be another example of another one to add? Let's say YouTube. Let's say that they're doing some type of training, right? That involves YouTube videos, for nurses and nurse practitioners. So we can add YouTube as a company and say, oh, YouTube has a terrible score. What's interesting though is that once you've created a portfolio, you can actually get a portfolio average, right? Which is a score for all the companies in the portfolio. So the average here is a D, right, for these two, because we have Box at an 88 and YouTube at an F. And it shows you what are the most common critical issues, aka some of the common attack vectors for your particular portfolio. And then you can do portfolio and risk management, and it shows you who's moving up, who's moving down over the last 30 days, moving averages, things like that. And you can continue to add companies here. What's another one? Brightspace, right? Maybe Brightspace is the learning management system that we're going to be switching to. So I think it was brightspace.com. So maybe the NYU nursing school has some custom content used for training and internal education and not just YouTube videos. You can see they have an 82, and you can see what their score is and look at their history and see if they have something to worry about over the last 12 months. Their score had a really severe drop here, but then it's been going up, and it looks like it's kind of bouncing around maybe as they patch and then fix things. But they're maintaining a pretty good posture here. There are some calibration events that happen, these little scoring updates where we're modifying every month the algorithms that are used to improve their accuracy. And these are the different events that have occurred. But anyway, that's enough of a demo for now of Security Scorecard. Let me jump back to the share of Google Chrome and continue with the presentation and pull up the notes again. Okay. So anyway, reach out to me if you haven't logged into it. You feel free to run the scorecard for any company you want in there if we have it, and we generally do. All right, next up, reconnaissance for penetration testing. I think I showed you this tool before, but I definitely recommend that everyone use Sublister moving forward. Sublister is a GitHub project to search multiple sources for host names, including DNS, caches, search engines, VirusTotal, all sorts of information. It's an awesome tool, and it's one of my first steps in doing any kind of vendor security assessment. I just want to pull down the list of all of their DNS entries that we can find. And then I run a security scorecard report. And between the two of them, I can get a lot of information about a company within just a few minutes. It shows a lot about how an organization is built from an application stack point of view to how they name things, right? DNS records give away lots of information about how a company works. So Sublister, very cool tool to be used for reconnaissance and to figure out which URLs and host names exist. And oftentimes the name of the URL or the host name will give away what the tool is, right? It'll say, checkpoint.something.com, or it'll say, what would be another example of another tool that just gives away the name, Jira. Right? And then that that's their Jira URL, or at least an alias for it. Another reconnaissance tool that you might want to use would be a WordPress WP scan. WordPress scan. This is part of the Kali Linux tools, or you can download it separately. I think it was last year. One of the targets for a student assessment was the makerspace at NYU. And so we ran WordPress scan against makerspace.engineering.nyu.edu to figure out what kinds of vulnerabilities were on the WordPress site for the makerspace. And then we gave that report to them to help them close those down. So WordPress scan is a great tool to use for reconnaissance because a lot of people do use WordPress, and there's a lot of vulnerabilities out there for WordPress. Spiderfoot. I think I mentioned this one in chat ahead of time that you should definitely use Spiderfoot to look at some of the targets. And so I think I actually ran this in another window, so I'll pull it up in a minute. Spiderfoot is a reconnaissance tool that automatically queries over 100 public data sources for OSINT, open source intelligence, to gather intelligence on IP addresses, domain names, email addresses, names of people that work there, and more. You simply specify the target you want to investigate, pick which modules that you want to enable, and then Spiderfoot will collect data to build up an understanding of all of the entities and how they relate to each other. I prefer to do most of the stuff through a command line. And I have the command line output open from running Spiderfoot, but there is a GUI that you can do as well. So this is the end of a run that I did against, pretty sure, what did I do? I did engineering.nyu.edu, so all of engineering. And I told it to generate that looking for metadata from files to spider the website and several other arguments. And then it wrote it out in an output file for me, right? Which is this one. So if I look at file, we can see information that was popping out of it. And in this case, this is raw file metadata coming from a JPEG image. And JPEGs contain lots of information as well sometimes. We know that it's stock.adobe.com photo that was used. And things come out here, the flash did not fire, right? So you have all this information about potentially, what was the shutter speed value. All this information comes out of the JPEG. And if we scroll down, we can find something a little more interesting than just a JPEG. There should be a PDF coming up here. So if I look forward in this output file for PDF, we can see that this particular PDF came through the Spiderfoot scan, right? Master's Thesis Project Report Guidelines from 2016. The title, Polytechnic University, before it joined NYU. It used to be called NY Poly or Poly. And the author is Jose Uleadio, and he created it using Microsoft Word version 2013, and the creation date was 2018. So that means that this 2016 master's thesis file was created in 2018 and modified in 2018 with what would now be a quite ancient version of Microsoft Word, and the author was Jose Ulerio. So what would an attacker do with this reconnaissance information? Well, they know that they could potentially email someone and say, oh, there's a problem, and you could name the author, right? You're disclosing information. This Jose person could be a university employee, or it could be the actual, well, I doubt it's the actual thesis, right? Because this is a thesis guidelines PDF. But it looks like some of these things are showing up in here, right? More than one author name. Actually, if I look for author, the capital O-A, we can say graduate academics is the author here. This one was using macOS 10.11, using the Quartz PDF generator. And so you can learn OS versions. Like I said, you can find out the author. In this case, it's not a named individual, but you know the name of a partner that's working with NYU Engineering to do requests to schedule dissertation defense for PhD. Scrolling down a little bit further, looking for some more authors that are not graduate academics. This one's interesting. Indirect object, no information. Skip that one. Let's look for another. Continue searching. Here we go. Here's Kevin Davis. The company is NYU. The creation date is 2016. They were using Acrobat PDF Maker 11 for Word, right? And so there's potentially a vulnerability for that. Or you can just find more recent ones, right? This one's from 2020. This one's not as ancient. And the author is Chris Day. For some reason, 15 MTC is included in there. I'm not exactly sure why, but you could basically spoof an email from this person and have it related to something they are working on, right? Which was academic personnel actions calendar. So anyway, you can find out all sorts of stuff about what's happening in a company with metadata that's in their PDFs and in the images files that they upload to their website. So Spiderfoot is a very cool tool to do that with. Let's see, jumping back into our share. No, that's not the one that we want to share. That's my slide notes for Spiderfoot. Where do I go back? Yeah, no, that is the right one, actually. Okay, so I have my notes, and you should be looking at the Spiderfoot web interface rather than the command line one that I was running. All right, next up, penetration testing, threat modeling, and vulnerability identification phase. Having gained sufficient intel on your target through LinkedIn or through security scorecard to see what the vulnerabilities are, or through Spiderfoot and tools like that. This is the pre-attack stage to identify various vectors, right? Compromises that you're going to try to achieve. In this phase, you can start modeling the threats that the client would realistically face, and you can identify vulnerabilities that will allow for those attacks. Here, the image is just a suspension bridge, showing vulnerabilities in the design and places that the bridge could be attacked, right? You could cut the main cable, you could, knock out the anchor, you could potentially cut, the underwater piers that support the bridge. Penetration testing. Now we're in the exploitation phase. The time has come to hack the system, to hack the code, to hack the people. This period usually takes about 1 to 2 weeks for a good test team armed with good intel from the reconnaissance phase. Of course, sometimes it will go even faster. I know folks that work at SecureWorks that do penetration testing, and they don't even get to have their first weekly meeting, right? Or even the next day. It could be 24 or 48 hours later. The pen testers have already achieved their target. The red team exercise have already achieved domain administrator on the company account, because they just found someone, fished them, got the malware in, set up a remote access Trojan, hacked the passcode through Mimikatz or something on a Windows infrastructure, and boom, game over, capture the flag. With all of the vulnerabilities that you've found by now, you should have plenty of possibilities and entry points to pick out and to choose from. That's why those phases are actually so important. In your rules of engagement in the pen test or in the red team exercise, you'll have identified what we call prized targets for the pen test. So go for those and go deep. You don't worry about trying to exploit all of the exposed or identified vulnerabilities. Just go for the ones that you know that'll get you the prize targets. Your team will win kudos for the speed with which you gain domain admin on the Active Directory servers, for example. All other targets are pretty much easy pickings once you've done that, right? So once you get domain admin, then you can, forge a credential that gives you access to the firewall, change a firewall rule, demonstrate that you did that by adding a comment to the firewall configs without actually changing their security or lowering their security during a pen test or a red team exercise. Next up, path to domain admin involves what is called the cyber kill chain. And of course, domain admin is usually, the major flag that's defined as a rule of engagement as a prize target. The typical path to reach domain admin will involve sending a phishing email, right? And first collecting and recon what kind of phishing email you should send and who you'd want to send it to. You then get local access, right? Patient 0, right? The one that's infected first by the malware that you sent the phishing email to. Or you just simply get their credentials because it was a credential harvesting phishing email. Then you install a remote access Trojan, a rat. That gives you persistent remote access to the device when it's online. And it could be a workstation in an office or a laptop, at home. You then explore unpatched privilege escalation vulnerabilities on that host to level up, right? So you have remote access as the user who clicked on the phishing email, but you want to get admin access. So you install a piece of software on there, you become the local administrator on the laptop. You then use Mimikatz to get the credentials of one of the client services team, right? Someone who has domain administrator privileges, not just local admin. And that allows you to move laterally to another workstation, right? Or to another server. Eventually you get on a workstation that belongs to a sysadmin or a domain admin, and you compromise those credentials through Mimikatz. And then you create a new domain admin account for yourself. You suppress notification of the event, of course, so that no one knows that this happened. Checkmate, it's game over, right? This path also begins and ends quickly with just leaving a USB thumb drive lying around in the office with a Microsoft Word macro vulnerability on it, right? The curious person picks up the USB stick, puts it in their computer, opens the file. Let's say there's a file on it called resume.doc, and they're trying to figure out who to give the USB stick back to, or they're just curious to see what's in the resume, and that's the Good Samaritan. Has just failed, the pen test for your organization. So Good Samaritans are a risk with regard to USB drives. Typically, you'd want to have a policy that prohibits use of USB read or write access from laptops. Everyone can get all the data they need nowadays, through their network interface, right? Through the internet, uploads, downloads. Moving around USB sticks and USB drives is limited to just a few people in organizations these days, and you can file exception requests for them to do that. All right, pen testing post-exploitation. So now that you have completely exploited the systems, you'll need to document the methods that you used, right? What devices and what accounts were hit and other relevant evidence of compromise. So you need to maintain that list as you work through the pen test, either as someone that's hired a pen tester to do it, or if you're actually working on the pen test team. You need to document what you went through and how you did it, right? To make it easier to close this phase, you should maintain that list as you go. And like I said, it should include which devices you compromised that were accessed, what were the associated vulnerabilities that were used to level up your user and get privilege escalation, what ports were involved, what personnel and accounts, whether you got someone from finance or from legal. Of course, they're going to have to rotate those compromised passwords and remove all the accounts and software that you installed as a part of the test. They also need to make sure that the rule of engagements requires you to report on critical vulnerabilities right away, not at the report at the end of the pen test. Critical vulnerabilities, people usually write a clause in there and say, don't wait 2 weeks to the end of the pen test to tell me about these. Tell me as soon as they come up. So that's why it's good to maintain the list while you're working. Make sure you communicate them in a secure manner as well to the target or the sponsor of the pen test. Don't just send an email with them, because that could be opening up the door to bad guys learning about it and exploiting the vulnerability before it can be patched as well. So a password protected zip file or a GPG encrypted message is the best way to communicate sensitive pen test findings. The complete report comes later so that they can actually ticket each finding and work on their plan to mitigate the risk and exposure of what happened. Shown here is a piece from the Battle of Hastings in 1066 from the Bayeux Tapestry, right? So this is sort of the carnage of what happens after the pen test, right? Red team always wins. Blue team rarely defends successfully. It's sad but true. The defenders usually lose. In terms of penetration testing reporting, this is much more detailed exactly what exploits were that you used to compromise their systems. Some pen testers like to use a 15-point scale. It really doesn't matter too much whether you use a 5-point scale or not for critical vulnerabilities or another, but basically this part of the pen testing is where you really earn your fee, right, for doing the work. You make it exceedingly clear how the attack was launched, extended, how the prize targets were achieved, or if not, if some of them were not successful, of course. The team receiving this report will need to be able to replicate the steps as they prepare mitigations and fixes. Let's say they think they fixed something. If you didn't write up how the exploit happened, they can't retest it themselves and verify that it's been fixed. And then, of course, they have to rerun the attack themselves to make sure that they've closed out those vulnerabilities. Another aspect of pen test reporting, here's the basics of what you need to include, right? More verbose logs and detailed outputs can be attached as an appendix. But this section should be preceded by an executive summary, right? A 1 or 2 page summary of the pen test and the high level findings. And each issue and risk should be given a number, all right, so that they can be tracked easily. You need to include the name of the issue, the severity, the steps to reproduce, and suggested methods of resolution, suggested approaches to remediation, and if that can't be done, then recommendations on mitigation, right? If there's no fix available for the issue yet, which could be the case if you used any zero-day vulnerabilities to exploit to get into the infrastructure or to take over a workstation. All right, so I've got another half hour. I have another 9 slides or so, and then I can do some InfoSec in the news with you. So scripting, infrastructure as code, and DevSecOps. These ones go pretty quick. Scripting, infrastructure as code, and DevSecOps. Let's talk a little bit about Terraform, TerraTest, and TerraGrunt. There are other infrastructure as code tools, but Terraform is one of the best from HashiCorp. Terraform is an open source infrastructure as code software tool created by HashiCorp. It enables users to define and to provision a data center infrastructure using a high-level configuration language known as HCL, HashiCorp Configuration Language, or optionally, you can define it in JSON. Terraform supports a number of cloud infrastructure providers, such as Amazon, IBM, Google, DigitalOcean, Linode, Microsoft Azure, Oracle Cloud, and others. Terraform lives at terraform.io. TerraTest, which I wanted to mention, is a Go library, which makes it easier for you to actually write automated tests for your infrastructure as code. Because you don't just sort of build the infrastructure as code once and then walk away. You have to constantly renew, refresh, and rebuild and keep your Terraform plans up to date. That way you can deploy a DR infrastructure in another region of another cloud service provider in case something goes down, right? And so that's not just a one and done kind of thing. And then TerraGrunt is interesting because it's basically a thin wrapper for Terraform that provides an even extra set of tools for multiple Terraform modules. So basically people were using Terraform and they're saying, this is awesome, this is great, but I want to take it one meta language level higher. And so TerraGrunt is a wrapper for Terraform that allows you to do that. And it makes it even easier for you to do infrastructure as code. Here I have some DevOps tools and some of their logos and where they fit in the entire life cycle. Yeah, under the coding section, we have tools, Git, Jira, Confluence, or any other wiki. Gerrit. Gerrit is a G-E-R-R-I-T, a great tool for, I think it's listed in here. It might not be. No, it's actually not listed. Anyway, Gerrit is great for peer code review. I think I've already shown Gerrit when we talked about the Wikipedia in one of the former previous lectures. Once we reach the build phase, We're talking about using tools like Maven, Ant, SBD. In the test phase, you've got something called Selenium, JUnit, JMeter, and BlazeMeter Taurus, Taurus. I'm going to give a quick demo of Taurus in a minute because it's a lovely tool that is really easy to use. And it's actually a wrapper for Selenium and JMeter. And so you can learn how to write JMeter test plans by writing up a very simple BlazeMeter Taurus test plan, and then it generates that JMeter test plan, which is an Apache project for you. Next comes the release phase. People should be familiar with things called Jenkins and CodeShip. In the deployment phase, you can have DCOS, Docker, Amazon native deployments for containers as well. In the operate phase, this is where things like Chef, Ansible, Kubernetes, and Puppet would live. And lastly, in monitoring, I'd already talked a little bit about Splunk, some of the DevOps tools of choice. If you can't afford Splunk, then maybe Elasticsearch or other. Nagios as a monitoring tool has been around forever, really hard to replace, a really well done tool like that. Datadog and New Relic are kind of the APM, application performance monitoring new kids on the block, but they're quite excellent and automated and scalable and highly performant, things like that. But let's take a look at BlazeMeter Taurus for a minute. And so I'm not going to run the one that I listed in my notes, but I did make sure that I have BlazeMeter ready to go. All right, so at this point, you should be seeing our Spiderfoot. So I'm going to CD to my documents and testing folder. I have a BZT folder for BlazeMeter Taurus, and I wrote up a quick test, quick NYU.YAML, right? Remember, YAML is an acronym for yet another markup language. So this is not a lot of code, and this is not really complicated code, right? Your eyes are not bleeding looking at this, right? This is very human readable, but it's also very structured, right? These number of spaces here, the 2 spaces here, and the indentation here of another 2 spaces, and the dash is very important. YAML doesn't work if you don't pay attention to your white space. So let's take a look at what this test plan does. It's going to run a concurrency of 50 in BlazeMeter Taurus. It's going to use 1 minute to ramp up. It's going to hold and test for 5 minutes. And the scenario that it's going to run is called quick test. But there's multiple scenarios that you can put into one of these files. Here is the scenario section, and this is where the stanza for quick test is. So I'm setting my header, and I'm actually declaring my username and the fact that I'm using BlazeMeter Taurus in it. I like to be able to find the log files later that I generated from my testing, or be polite to other people. They may not know Wilkes and who I am when I hit them, but this is just a few tests of some nyu.edu URLs. We're going to upgrade insecure requests. That's going to be set to 1. And then we're accepting, right? We're setting a header for what type of responses that we can return and receive, which includes XML and HTML images and things like that. We also accept compression from the server, and we accept the English language, ENUS, which is a locale, right? US English. And then this is the request stanza. So it's going to go and pull this request, which is searching for Wilkes on NYU search page. It's a GET request, and I'm giving it a label for my results, because otherwise this whole long string becomes the request, and it just uses up too much real estate. Then I've labeled the next one, pull down the NYU sitemap, which is used by robots, and that's going to be a pretty heavy call, a pretty heavy request. This one, though, is not very heavy at all, robots.txt. Not everyone, most people in the world publish a robots.txt page, and I'm labeling that robots. And then I'm just doing a basic header on accepting the response as JSON for fun. So what do? I say which BZT. I already have it installed. If you don't have BZT installed, you would use Homebrew and say install BZT. And the cool thing is that it installs Selenium and JMeter for you as dependencies. And so you get this great little command line. You just type BZT. And there's a web portal, and you can run BlazeMeter tests on there, and they let you do like 20 concurrent users for free. Not really heavy load testing with 20 concurrent users, but for functional tests like this. And then I'm going to run quick nyu.yaml, and that's it. The cool thing that this thing does is it says, oh, there's a new version, you can download it. But anyway, it throws up a graphical VT100 kind of emulated, and it fires up the test. And this is what I think is kind of fun. You can obviously turn this off and make it a part of your CI/CD pipeline. And it's going through and it's saying, okay, Wilkes is failing. Remember that label? It's doing a search. Why is it failing? It's failing for a forbidden error. So I need to have some type of cookie before I can do a search of NYU. So this is, I left this in the test because it's useful to see that the response times on the error page is coming back pretty good, right? 1 second, this is measured in milliseconds. But it's telling me what's the elapsed time and the latency. It's doing some graphs over here, right? We were going to get up to like 50 concurrency, I think. It's up to like 28 now, 32. It's showing which ones are failing, which is just this Wilkes request. The sitemap is coming down, and it's had 300 requests of those so far. And the robots.txt file is coming down, and that's coming down much faster. So look at that. It's only like 90 milliseconds. The sitemap is taking like 330 milliseconds to return the response. You have your quartiles and percentiles. 50% of all the requests are coming back within, a third of a second. 90% of all the requests are coming back within 2.5 seconds. And of course, this is the one that's killing us, right? This error message on Wilkes is taking a long time to parse. And so if I took that out of the test, the throughput would be a lot different. So it looks like we're at 50 users that are synthetically being generated, and we're about 25% through the test so far. And again, I said just run at this level for 5 minutes. It's using a fair amount of resources on my local machine. I'm using 50% of the CPU, 70% spikes. I'm using about 64, what's that, megs of memory. Disk read speeds and disk space that it's consuming. And so anyway, this is Taurus. I can shut it down just by doing a Control-C. We don't need to run it for the 5 minutes. But what's cool, and what I wanted to show you, and we'll let it shut down. So it fired up a complete JMeter instance and then Selenium to do the test rounds. And so the fact that you can automate those tools with this very simple format and do basic web testing, it gives me some nice output. But if you did this headless, meaning you didn't actually fire up all that information that we just saw on the screen, you could make it a part of a Jenkins job. Someone does a build, you could do a performance test to make sure that the performance hasn't tanked between the last time a test went out. And the interesting thing is it created this lovely folder for me from the test. So if I CD inside of that folder, there's some artifacts that got generated, right? One of them is a modified request JMX text file. And of course, the requests.jmx. So if we look at this file, this is something you could actually import into JMeter. And JMeter is a great tool to learn as well. But basically, it generated this test file for me based on the YAML that I said, right? So it created thread groups. It had caching information and different properties. Here's one of the search strings, right, that it was looking for. And it has timeouts and information that's all there. This one was the test request looking for robots.txt. So basically, you can copy this JMX file into a JMeter test plan, and then you could add more variables to it and then save it. And then you could wrap it up again inside of a BlazeMeter test. There's a log file that has some of the output and some of the other information. It captures the YAML that we did just to make sure you have it later to notice what types of tests were run. But anyway, very powerful tool, command line testing and performance testing. And, like I said, you can upload these test plans to JMeter and to the BlazeMeter website. You can buy a subscription. You can run synthetic tests from like 10,000 users from all over the world because they have footprints inside of Azure, inside of Google, inside of Amazon. And so you can really generate a lot of synthetic load and fairly non-trivial test plans as well that you can incorporate. This one, I think, was quite trivial. It's just 3 different pages, one of which failed out every single time it made the request. And you can see the sitemap performance was pretty bad compared to the robots.txt file. Maybe the sitemap is big, right? How many bytes was it? And then there's the BZT log that you can parse later to figure out if anything broke. So anyway, that's BlazeMeter BZT, BlazeMeter Taurus. Let's go back into the deck and finish it up as we head into the end of the series of slides. I think I have another 6 or so slides to go. Next up, compliance automation. Actually, I have one more in here that I forgot to add to this slide, but I did add the slide, so we will see it. There's 4 compliance automation tools that I wanted to mention in this lecture. And shown here is an apostille. Many of you that are international students may be familiar with the concept of the apostille. The Hague Convention abolishing the requirement of legislation for foreign public documents. The Apostille Convention, or the Apostille Treaty, is an international treaty that was drafted by the Hague Conference on Private International Law. It specifies the modalities through which a document issued in one signatory country can be certified for legal purposes in all of the other signatory states. So I, for example, had to have an apostilled version of my US birth certificate when I moved to Holland and to live in the Netherlands. The same would be true if you wanted to move to many countries that participate in the Hague Treaty. So I thought compliance automation, it would be fun to have a little aside about apostilles. And this is an example of what some New Yorker, I believe, apostille. And so the New York Secretary of State would have to issue it, for any legal document that you have here to be recognized as a valid legal document in another country. So what are some of these automation and compliance tools? Chef, there's a tool from Chef called Inspec. It's a language for describing security and compliance rules that can be shared between software engineers, operations, and security engineers. Compliance, security, and other policy documents become automated tests that can be run against traditional servers, against containers, against cloud APIs, ensuring that enforced consistent standards in every managed environment at every stage of development. This is an open source software, and it has a fairly active community when I last checked. So Inspec is one way to automate some of the compliance testing. Another format and ecosystem to refer to is OpenSCAP. SCAP is a Security Content Automation Protocol. This is a US standard maintained by NIST, the National Institute of Standards and Technology. OpenSCAP has a wide variety of hardening guidelines and configuration baselines developed by the open source community, ensuring that you can choose a security policy that best suits the needs of your organization. OpenSCAP policies are machine-readable descriptions of the rules that your infrastructure must conform to. The URL for this is in the slide notes, but it's basically open-scap.org. And this is a great initiative to support and participate in. I think you can actually run OpenSCAP scans against AWS infrastructure, and several cloud service providers make that possible as well. The next tool I wanted to mention was Dome9 from Checkpoint Software. CloudGuard is a rebranded version of what was Dome9, which was an acquisition by Checkpoint. It's a comprehensive software platform for public cloud security and compliance orchestration. So remember, we were talking about SOAR before. All sorts of vendors are branching out into the place of orchestration, and Checkpoint has one as well. The last one I wanted to mention, which I didn't put in the list, so I'll have to remember to add it to the slides before I save them and share them with you, is a small startup that is called SecureFrame, and they're founded by Shrav Mehta and Natasha Nielsen. The company raised $18 million in Series A financing, led by Kleiner Perkins. And if you've ever heard of Kleiner Perkins, you know that they're a pretty picky venture capital investment firm. And they also had participation from Gradient Ventures and Base 10 Partners. And Base 10 Partners actually led the first seed round for SecureFrame with a $4.5 million investment round. And what's amazing is that this $18 million Series A happened less than a year after it was founded. The company was founded in, I think, January of 2020. And SecureFrame's, sorry, the 4.5 million came that fast, because this 18 million just happened last month, if I remember correctly. SecureFrame's compliance platform integrates with dozens of cloud service providers to try to generate automated collection of artifacts needed to help a company achieve a SOC 2 audit, a HIPAA audit in Q3, I think, is on their roadmap, and of course ISO 27001 certifications. if you've not heard of ISO 27001, it's the more European and international standard, right? In the US, a lot of people do SOC 2 and NIST certifications and compliance. But if you want to have a data center or an organization that's in global in reach, you're going to go for one of the larger standards like ISO 27001. And SecureFrame can help you automate that. And so I wanted to give them a bit of a plug in this class. And also I posted a note in my LinkedIn about it because I think it's an up and coming, very, very exciting development, because people spend, weeks, not weeks, people spend months trying to bring their platform into a SOC 2 Type 2 compliance standard. The difference between SOC 2 Type 1 and 2, I think we talked about it already, but I'll mention it again. SOC 2 Type 1 is a point-in-time audit. SOC 2 Type 2 says, not only did you pass all the stuff at that point-in-time moment, but you also do it as an ongoing practice, right? It's like a regular, recurring thing. So if you do security rights audits of your users, if you do one audit once every 12 months, you can be Type 1 compliant. But if you do it every quarter or every month, then you're SOC 2 Type 2. And it's a much more stringent and valuable certification to have for people to trust you. So that was a long lecture. And the reason it was is because I rolled in a complete other set of slides to fit what was a 14-week curriculum into this 12-week offering this semester. So that's one of the reasons why there were more slides, 70 slides instead of my usual 50 or 60. But those topics go well together. So let's spend just a couple minutes looking at the InfoSec and the news and finish up our last 5 minutes of time together today. So full share, Slack, InfoSec and the news. All right. Let's see, some Reddit articles. And what are we looking for? We're looking for automation and testing, right? SPIM is a tool to automatically create custom reverse shell codes. Certainly automation, but more from a hacking point of view. I'm looking more from a InfoSec professional's point of view. Hands-on information about Windows 10, no. Android malware found embedded in APK Pure Store application. APK Pure, a popular third-party Android app and an alternative to Google's official Play Store. Oh, well, of course, that's a supply chain attack. That's automation of bad stuff. That's not exactly this week's topic, but good story to look into. I guess APK Pure showed up in a couple of places. They tampered with it. Actually, let's take a look at it. There's no reason not to, right? Even though it's not 100% germane, it's a good topic for these last few minutes. Hackers tampered with APK Pure Store to distribute malware apps. So if you don't want Google Play Store to be your source of apps, APK was infected with malware this week, allowing threat actors to distribute Trojans to Android devices. In an incident that's similar to German telecommunications equipment manufacturer Gigaset, the APK Pure client version 3.17.18 is said to have been tampered with in an attempt to trick unsuspecting users into downloading and installing malicious apps linked to the malicious code built into the APK Pure app. The development was reported by researchers from Dr. Webb and Kaspersky. This Trojan belongs to the dangerous Android Triada malware family, capable of downloading, installing, and uninstalling software without the user's permission. Joker malware infiltrates Huawei app gallery. APK Pure is not the only third-party Android app hub to encounter malware. Earlier this week, Dr. Webb researchers disclosed it found 10 apps that were compromised with Joker or bred Trojans in Huawei's app gallery, making the first time malware has detected in the company official's app store, in the company's official app store. The decoy apps, which took the form of a virtual keyboard, camera, and messaging apps from 3 different developers, came with hidden code to connect to command and control server. I'm gonna have to talk to our threat intelligence researchers and see if they're tracking this one, because this one should definitely be on our radar for our sinkholes, right, to see what the extent of this is and how many companies are being hit with this APK backdoor. Let's see, how to set up two-way integration between AWS Security Hub and ServiceNow. That's an automation tactic or topic. Yeah, we can definitely open that link. A lot of the AWS blog posts are quite helpful, right? Because they're taking pre-chewed food almost, right? They're telling you this is a quick way to do this really awesome thing that would take you like, a month to figure out on your own or longer. So this one was published April 9th. If you use AWS Security Hub and ServiceNow, they have a management connector service, which makes it easier for you to put these two together. So to complete this walkthrough, you need a ServiceNow instance available, the connector configured, and AWS Security Hub. On the AWS side, you'll need Security Hub enabled on your account. Walk through the CloudFormation template to create the necessary AWS resources for this integration. So they're saving you the time of having to create that CloudFormation template. You can download the formation template here, and then it has specific stack details that you have to put in. Create the stack, which is like a multi-server blueprint, essentially. Really nice screenshots, good documentation here, masking out the information that is sensitive, like the AWS account name or number. Let's see, integrate with ServiceNow, some more screenshots. So anyway, these kinds of automations are helpful. So why would you want to do that? Well, you would want to have security violations potentially open up a ticket in your ticketing system, right, in ServiceNow. And so I presume that's what it's going to do, right? It's going to open up an incident, and you could say severity medium, and maybe do mappings based on what Security Hub says as to what the severity is. In ServiceNow, change the urgency to 1, for example, if you know that you're pulling highs off of Security Hub. And you're doing something that a human may have to do at the moment if you have both of these solutions. And so that's the goal, of course, of automation. Tie these things together in hopefully a loosely coupled way so that they're not fragile, and then select the severity of findings that you're going to use to create incidents. So you don't necessarily want to create a ticket for every low finding, right, that might come across Security Hub. You might want to do just criticals, see how that feels, then do criticals and then highs, and then maybe work your way down from criticals to highs to mediums and see what that workload is like. But creating this integration, very handy bit of automation. Let's see, one more thought. Oh yeah, did we talk about this? No, we didn't. CISA launches a new threat dashboard. CISA is the Cybersecurity Infrastructure Security Agency, the darling of the Department of Homeland Security at the moment, and they released something called Aviary. And so let's spend one more minute on this. Using Aviary to analyze post-compromise threat activity in Microsoft 365 on-prem environments, because it didn't affect the cloud for Microsoft OS 365. So Aviary is a new dashboard that CISA and partners have developed to help visualize and analyze outputs from its Sparrow detection tool, which was released in December. So this is a link to Sparrow, and you can read about Sparrow, download it. It's all built on top of Splunk, actually, though. And so Sparrow is a bird. You can think about, canary in a coal mine. That's like a police song that Sting used to sing. And the bird would sort of start chirping or fall over dead if there was carbon dioxide or carbon monoxide in the coal mine. And so the miners would get out, right? And so that's sort of what canaries are for. They're kind of like honeypots and early warning detectors. So if we look at Aviary real quick, Aviary press release talks about how to make a Splunk dashboard, essentially, out of this, and to pull the data sources in from Sparrow. And hopefully they have no picture, but they do have the Aviary XML and the source code. Let's take a look at that XML real quick and see what it's doing in the dashboard. Oh, it's going to open up Xcode. That's too bad. I don't need to open up Xcode just to look at XML. It is text file. So let's just jump over here. LGDO less aviary.xml. So they're saying earliest event, latest event. There have some buttons. They have a panel. They're probably pulling information, right? Make results. Oh, looks like they have an emoji. And what else? Data selection filters to figure out what you want to look at, what types of events are being triggered. Here it's pulling in, some of the CSVs that are mentioned on the page, operations, lease assignment operations. Anyway, so they're automating all of this for you and making it easier to just import this dashboard into Splunk and making it possible for people to be safe even after they were compromised by the Russians Oh no, or the Chinese. I think it was Chinese that were APT 10 that were called Hafnium. But there were a lot of other threat actors that piled on and continued some of the same exploits of those Microsoft Exchange environments on-prem than just the Chinese. There's lots of other threat actors taking advantage of them as well now. So that's it for this week. A packed lecture. Send me any questions you might have in Slack or in email. Catching up on grading assignments. I did a couple more, or at least one of them this week, and I'll be following up on closing out, getting your grades as we head into the final week 10, 11, and 12 to finish up the course. So that's it. Thanks for joining, those of you that were dialed in, and we will see you next week, right? Or wait, no, next week is another week off, isn't it? I have to look at the syllabus. I have to double check. But anyway, cheers.